the EJSA1 channel. Stick around.
Discovery, go at throttle up. Discovery, go at throttle up.
Attention all personnel, this is the NTD conducting the launch status check. Verify ready to resume count and go for launch. OTC.
OTC is go.
TBC.
Tank and booster go.
TTC.
TTC is go.
LPS.
LPS is go.
MILA.
Milo is go.
STM. STM is go. Safety console.
Safety console is go.
SPE.
SP is go.
LRD. LRD is go. SRO.
SRO is go. You have a range clear to launch.
And CDR.
CDR is go.
And Launch Director NTD, our launch team is ready to proceed.
I copy that. I'll do my poll at this time. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
Safety and Mission Assurance is go, Mike.
Thank you, Terry. Payload Launch Manager.
Hey, Mike, on behalf of the ISS Ground Processing Team, I want to say thanks to you and the shuttle team. It's been a great partnership, and we are go.
Thank you, Bill. Appreciate that. Range weather.
Launch weather has no constraints for launch.
Thank you, Kathy. Atlantis Flow Director.
On behalf of the Atlantis and KSC Civil Processing Team, we are go.
Thank you, Angie. Atlantis Launch Director, Air to Ground 1.
Atlantis go.
Okay, Fergie, we're starting to feel pretty good down here on the ground about this one today. So on behalf of the greatest team in the world, good luck to you and your crew on the final flight of this true American icon. And so for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, and have a little fun up there.
Hey, thanks to you and your team, Mike. Until the very end, you all made it look easy. The shuttle's always going to be a reflection of what a great nation can do when it dares to be bold and commits to follow through. We're not ending the journey today, Mike. We're completing a chapter of a journey that will never end. You and the thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's light this fire one more time, Mike, and witness this great nation at its best. The crew of Atlantis is ready for launch.
Yeah, let's just go for orbital access armory track.
Atlantis, this is OTC. This day has been over 30 years in the making. There have been many fabulous missions throughout the years. On behalf of KSC launch teams, past and present, we salute the entire astronaut corps for their dedication, not only for our expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Fantastic words, Roberta. Thank you very much. Great to your team. Thank you, sir.
Sequence start.
And off to Atlantis' computers has occurred. Solid rocket booster nozzle steering check and work.
20.
Firing chain is armed.
15.
Go for main engine start. T-minus 10, 9, 8, 7, 6. All three engines up and burning. 2, 1, 0. And liftoff, the final liftoff of Atlantis. Shoulders of the space shuttle. America will continue the dream.
Roger roll, Atlantis. Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. 24 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 40 seconds into the flight, the 3 liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time. Atlantis flexing its muscles one final time. Atlantis traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange, standing by for solid rocket booster separation.
Field inside Houston.
Copy, Atlantis. Field inside. Landing gear down and locked. Main gear touchdown. Hurley now deploying the drag chute. Ferguson rotating the nose gear down to the deck. Nose gear touchdown. Having fired the imagination of a generation, a ship like no other, its place in history secured, the space shuttle pulls into port for the last time. Its voyage at an end.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
We copy your will stop, and we'll take this opportunity to congratulate you, Atlantis, as well as the thousands of passionate individuals across this great spacefaring nation who truly empowered this incredible spacecraft, which for 3 decades has inspired millions around the globe. Job well done, America.
Hey, thanks, Butch. Great words. Great words. You know, the space shuttle's changed the way we view the world, and it's changed the way we view our universe. There's a lot of emotion today, but one thing's indisputable. America's not going to stop exploring. Thank you, Columbia, Challenger, Discovery, Endeavour, and our ship Atlantis. Thank you for protecting us and bringing this program to such a fitting end. God bless all of you. God bless the United States of America.
What is that venting right now? Yeah, there could be a bunch of things, dude. I forget what that vent line is for. It's been a while, dude. I used to get questions about the shuttle all the time. Not so much anymore. I'm gonna go ahead and guess it's probably the hydrazine APUs. Yeah. It's probably venting decomposed hydrogen, because how the APUs worked is on monopropellant on the shuttle. The shuttle had 3 redundant auxiliary power units in the aft end of the vehicle, and they basically throw hydrazine in a monopropellant tank in a COPV through a bladder, and it goes through a catalyst, and that catalyst, when it combines with when the hydrazine hits the catalyst, it heats up, and that turns a turbine, which generates power. Yeah. So he's probably venting the hydrazine APUs, but also crew farts. Yeah, no, that's a different vent line, believe it or not. The urine, the waste receptacle vent line is actually on the bottom of the shuttle. It's on the bottom sides by the body flap. So if you're wondering why we're watching this in the first place, today marks the 10-year anniversary of STS-135. It was the last shuttle mission. Atlantis flew to the ISS for a resupply mission and came down and promptly concluded the shuttle program. That sucks. It sucks. The shuttle is... Look, I get it. People like the Saturn V. I get it. I get it, but nothing... There's not much that'll come... There's not much that'll come close in terms of coolness for that thing. The shuttle is insane. It's insane. It's insane in the best way possible. It shows the best of what we can do. It's crazy. You know, for all the things, you know, that happened with the shuttle program, it's still ridiculous that it works as well, that it worked as well as it does. I love that thing. It is the vehicle that helped me get to where I am today. It inspired me, just like what Ferg said right at the end there.
Listen,
hey,
quality base here. The Eagle has landed.
Thanks, man. It's pretty much the reason why I love space as much as I do. The shuttle's insane. You know, you look at a capsule, right? You look at something like the Apollo CSM or Soyuz and stuff, and you say, okay, you know, you look at Gemini, you look at even Dragon and Starliner and Orion to an extent. And you're like, okay, you look at the shuttle, anyone on the street, you show them a picture of the space shuttle, they're going to go, that's a spaceship. That thing goes into space. Show them a pod, they're going to be like, alright. You show anybody that, and that's a spaceship. That thing flies. It flies into space and comes back. It's a space plane, right? You show anybody, it could be, even to this day, 5-year-old, 6-year-old, you show them that, they'll be, oh, space shuttle. Anyone. You stop anybody on the street, hey, what's this? That's the space shuttle. That's a spaceship. It flies into space. You know, you just don't get that with pods, all right? Yeah, Reed Dog, I know what you mean, man. I love this space shuttle, and I'll never stop loving the space shuttle. It's the launch vehicle that I grew up with. So it'll always hold a certain nostalgia in my heart. God, I miss that thing. The capability, dude. It's such a good launch vehicle. Yeah, and I get it. It's more expensive, you know, but it also does more things, you know. We could sit here and say, oh, it's expensive compared to Dragon. I mean, yeah, a pickup truck is going to do more than a smart car. Is it more expensive? Yes, absolutely. A semi-truck is going to do more than a freaking Toyota Corolla, except deliver tofu. That's the one exception to that rule, but different story. You know, you got what you paid for with that thing, and the only thing that would have brought that cost down is launching it more, not less. You know, it's just, it's tough, man. Even 10 years on, my mind still tells me that the space shuttle's still flying. Nope. Nope. I miss it. I miss it a lot. Yeah, that's a good video, W. Hey, Snake. It's a relic. Once was beyond cutting edge, but it now has outperformed pretty badly. Still started the satellite age. What outperforms the shuttle, Junk? Seriously, what outperforms it? Last time I checked, we don't have a capsule yet, and hopefully that changes in November, man. We don't have anything that can go beyond low Earth orbit. You know? What outperforms the shuttle? Nothing outperforms the shuttle. For a low Earth orbit access vehicle, it's about as good as you can get. Hopefully Starship, maybe. That's how cutting edge that thing was. The design's from 1972. They drew up the shuttle on friggin' blueprints. And it's still good, you know, because, well, physics don't change. They freaking broke the mold with that design. It's really, really good. Starship can do the shuttle's job, right? Yep. Can the shuttle go beyond low Earth orbit? No. No. Submitted, the idea is that if you make a good pathway into low Earth orbit, you don't need to launch a bigger rocket. You can launch the shuttle more frequently and build stuff in space. That's what it was designed to do. It's basically a... You know those trucks... There's like a flatbed truck that has the crane on the back. That is a shuttle. The shuttle is that in spacecraft form. You know? I have some news on that, Buck, but yeah. It's absolute beast of a vehicle. Isn't it easier and uses quite a bit less fuel to have a capsule design? It's See, Junkyard, it's a fairly diminishing. It's not a diminishing return with space flight, dude. It's like, okay, Junk, you know cars because from when we were playing Beam a little bit earlier, right? With say you're buying suspension components, right? If you buy some crappy aftermarket suspension, right, that was made somewhere overseas, I won't say where, but we all know what I'm talking about. It's not going to work as well as if you sprung for the better suspension. Ha, sprung, right? You get what you pay for with car parts, right? Rockets work the exact same way. You get what you frickin' pay for. So yeah, the shuttle uses a little bit more fuel, right? In terms of straight quantity, but that's not a good metric for measuring rockets either. Like, you need more fuel because you're accelerating more payload up into orbit, right? Like, the shuttle's way bigger than a pod, so you're going to need more fuel to move that thing up there. Just like, you know, a smart car can't tow a gooseneck trailer, right? And even if it could, somehow, like, you wouldn't be able to pull anything, right? You need something bigger with more power, right? Rockets tend to scale like that pretty linearly. It's not super linear, but it's close. You know what I'm saying? Like, you get what you pay for with the shuttle, and that's always been what I'm saying. Like, you know, people look at these pods, right? And these pods are great, right? Don't get me wrong. I like Dragon 2. Dragon 2 is amazing. I have it right here on my display, right? I like Dragon 2, and I like Starliner, and I like Orion. They're great. And I think that Orion is the right move for going beyond low Earth orbit. If you're going out to the moon, you really don't want to bring a shuttle out there. That's not a good idea. But, you know, in terms of low Earth orbit access vehicles like Starliner or Dragon 2, right? They only move 4 people into space. The shuttle could move 7. On one mission it moved 8, right? 61A, right? We talked about that the other day. You know, the shuttle is 4 times expensive, but you have 4 times the capability. The capabilities, what I mean is the capability scales pretty linear, right? So, like, say the shuttle was, say Dragon 2, I think it's $10,000 a kilogram to get into space. The shuttle was way higher than that. The shuttle was like $25,000 a kilogram. But you got to remember, you get what you pay for here. The shuttle can do more things in space, right? The justification that the shuttle is more expensive, you know, and I've always thought this was Bush League stuff, right? Everybody said, "Oh, the shuttle is too expensive. The shuttle's too expensive. Shuttle's too expensive." Well, that's like owning a trucking business and saying that a semi-truck is too expensive to operate. So I'm going to use pickup trucks instead. It's like, you own a trucking business. Yeah. Instead of like one big semi-truck, we're going to use a bunch of small pickup trucks to move the same amount of stuff. It'll be cheaper. No, it won't. No, it really won't. You know? I just thought it was a beast to get that thing into space. Oh, don't get me wrong. Shuttle flies about as good as a brick. And when it's on the side of a rocket, you're accelerating a brick into space. But once again, it's supposed to fly like a brick. That's what it's designed to do. All the aerodynamic surfaces on the shuttle are designed for when you're coming back down. And when you're coming back down, you want to slow down, or else re-entry heating does its thing, and we all know how that ends. Not having the Canadarm on a ship right now is a massive loss. Or an airlock, Apatoxin. An airlock, Canadarm, you're losing all that capability. And I don't think that's something that we really thought about, you know? For instance, Hubble's broken right now. Oh, geez, it'd be nice if we could, you know, go and fix it. But we can't. We don't have an airlock on a spacecraft, and we don't have an arm to go and wrangle the thing. Now, don't get me wrong. They installed a docking port and a grappling adapter on the Hubble during the last servicing mission so something else could get at it. But, I mean, there's one vehicle that's like explicitly designed to do stuff like this, and yeah, we chose to put it in a museum 10 years ago, you know? But hey, you know, hopefully Starship avenges it. Starship will vindicate the shuttle and vindicate reusable launch vehicles, because another thing that got peddled around a lot when I started streaming, what, 9 years ago, was that, oh, the shuttle's shuttle's a piece of junk. It's a piece of junk, you know, it's not a good launch. You know, that's you know, reusability doesn't make sense. That was the big one. Oh, reusable vehicles don't really make sense. The shuttle proved that reuse doesn't work. The shuttle proved that reuse doesn't work. Yeah, okay. This guy Wario would like to have a word with you on that. Yeah, it's stupid. It's dumb. No, it absolutely does make sense. You have to have the right circumstances, and the shuttle never had the right circumstances. You know? Could they rebuild the space shuttle? Nah, don't even bother. Don't even bother. Yeah, we're way too far out of the gates. It's not even worth it. Let's just hope that Starship does what Elon Musk says it's going to do and just go from there. But anyway, today is the 10th anniversary, and I'm happy that so many people, you know, love the shuttle as much as I did. It really, really makes me happy. They test fire the vacuum Merlin engine without a nozzle, And they do test fire alleviate. Your question is, do they test fire the Vacuum Merlin and Vacuum Raptor? Yes, both of them. Vacuum Merlin engines are tested without their nozzle, so they don't get overexpansion. And Raptor vacuums, you don't need the chamber pressure because of the stage combustion cycle is so high that you could test vacuum engines at sea level and it'll work just fine. I mean, the X-37 could go get Hubble with a robotic arm and bring up some parts for it. No, it couldn't. No, T-Man. Hubble's bigger than the X-37, man. What is this? Well. Oh, yep, that's the end of that. Yeah. Isn't Hubble way out there? No. It's about 270 miles that way. Is it 337? Sorry, I know where it is in metric. That's right. It's not where the ISS is. It's higher than that. It's at 500 kilometers, which is not 270. It's 330. There you go. But yeah, anyway. I know the shuttle arm was key to servicing Hubble and unique, but have you ever seen a conventional rocket design that could accommodate an arm like that? It's possible, Jekyll. But any other conventional capsule design is basically going to have to expend the arm. There's no way you're going to get it to fold up in front of a heat shield or something. I mean, you could. I don't know how you'd accommodate that kind of mass and how you'd get it back down, but I mean, yeah, I'm telling you, dude, they broke the mold with the shuttle's design. The shuttle is great. It's a fantastic design. I will die on that hill. Like, there's not a better way to do it. Starship, maybe, but that remains to be seen. But even then, Starship is taking a lot of cues from the shuttle, you know what I mean? James Webb is the one that's going to be way out there. It's going to be on the other side of the moon. Yeah, far side of the moon. Shrubber, you see how quickly that fairing snapped? That's how delicate those things are. They snap very easily. Did Buran have an arm like that? Yes, Buran did. Of course. It's just a copy of ours, but whatever. It still did. Shuttle had so many wacky things. Isn't that where Inconel came from? I'm not sure if Inconel came from that specifically, Junkyard. Maybe a certain alloy of Inconel, right? But some of the things that the shuttle brought to the table is an overwrapped pressure vessel, which literally every rocket uses nowadays. Probably why they stopped. Oh. Running into an issue where KSP, where control from here on the Mark docking port isn't working. I haven't... On the Mark II docking port? I don't remember it having an arm. Chem, it has one. Why wouldn't they? Well, Chem, okay, why wouldn't they? Why wouldn't they make the arm? The whole point of Buran is to match capability. It has to. Has to have one. I don't know whether they made one. I have no idea. I know that it was planned, dude. It had to have been. Like, I mean, you look at all these renders all over the place. It has dual arms. The shuttle could do this. Shuttle could carry 2 arms, actually. Yeah, so it could hold something and manipulate the other side. They're old. Those are old videos, Fishio, yeah. I mean... fairly confident that they would have given that thing one. I mean, I'd have to look at Buria's payload bay. If you could get me a picture of Buria's payload bay, I'll be able to tell you. I know what the attachment fitting looks like on the shuttle, and once again, Behrens is probably pretty damn close. I agree, Kuro. Yeah, absolutely. The shuttle and Buran look amazing. It's such a nice. It's just a. I don't know. It looks weird at first, but then you get used to it, and you're like, oh man, it's a really nice design. It wasn't the Canadarm C-22. It was the Belarus arm. Actually, most likely Ukraine. Soviet Union had a lot of subcontracting for aerospace in the Ukraine. Apatoxin, it really is insane. The shuttle is ridiculous. It's ridiculous how they were able to predict how a hypersonic flows with no computer simulation. Like how the plasma was going to move around the vehicle. It's ridiculous that they were able to figure that out at all. It's unreal. Like, testament to Rockwell's engineering. It is. I mean, it shouldn't have. Like, how do you even go about predicting that? Oh, yeah, there it is. Yeah, that's very, very similar to the grappling end effector on ours. It's very similar. It's pretty much the same. Here, I'll show you. Can you explain going supersonic to me? I'm fascinated by it. I've been watching some movies where supersonic speeds occurs, but having a hard time understanding it. Basically, the air moving over something is traveling at a speed faster than how the speed of sound, faster than sound can travel. That's the basic of the basic. It's all about how the air flows over the vehicle. Sound travels at a certain speed. Now that speed can change with temperature and pressure and stuff, right? But sound travels at a certain speed at sea level, right? And when the air moving over a plane goes faster than that speed, you break the sound barrier. Yeah. Kuro, like you said, growing up with this design my whole life is something magical about it. It's just so damn cool, dude. Yeah, W. We've talked about that before. But anyway, let's, that's the STS-135 tribute. Let's keep going. So, speaking of space shuttles, Sierra Space posted this today, actually. Building on the legacy of NASA's shuttle program, we're working to launch our very own shuttle. The Dream Chaser spaceplane. Today we honor the 10th anniversary of the shuttle program's final flight. We can't wait to be a part of spaceflight history's next 10 years. There you go. There's the next generation shuttle right there. A pic inside. It's low res though. Let me take a look. This is very similar to the shuttle's payload bay. It's very close. Even down to where the fittings are. It's very similar. So, yep, okay. Yeah, you can't tell from this picture. It's the components haven't been installed. Yeah, see, COPVs. They're in very similar spots to where they are on the space shuttle, believe it or not. That's a neat looking shoe. Here, I'll show you what that's supposed to look like. Sierra Space is working on Dream Chaser. It's a little mini space shuttle. Oh yeah. No. Open. Yes. Jeez. It's cool. It doesn't have the coolness of the space shuttle, though. But it is pretty damn cool. The center mass was different for that matter. Yeah, Kem, it's not as far off as you might think. They put naphthyl thrusters in the back, dude, if I'm remembering right. There's a huge fuel tank back there instead of there's a huge fuel tank and 2 engines back there instead of the 3 mains, you know? Also, F-350 Super Duty with the dually. It's pretty rad. Yeah, that's Dream Chaser. We're going to get an unmanned variant, so it's going to look like this, only less balloony. I still don't understand how the front leg works. It's a skid plate, Swishio. Like a piece of wood. It's just it's not, well, there's like a little, it's not wood, it could be something else, I don't know. It's a skid plate. Because they can't fit a wheel up there, dude. The reason why they can't fit a wheel up there is because the pressure vessel's in the way. See the pressure vessel? So, okay, all right, here. All right, we're going into paint. Going into paint, bros. All right, so you have the back of Dream Chaser, right? And then you have the front, right? And then, right? This is basically what Dream Chaser looks like from the side. The pressure vessel, so the usable cargo area, looks like this. It looks like that, for the most part. Actually, it's more like this. It follows the profile, right? And then this is where your windows are. So with the front landing gear, you could fit the arm, but you can't fit a wheel right here. Reason why you can't fit a wheel right there, once again, pressure vessel's in the way. That's the reason, dude. Straight up. That's why it has a skid in the front. And like your wings are back here, right? And then it has a little guy like that. Yeah, so this is your usable volume. And the docking port on Dream Chaser is actually in the back. It's back here. It's it's not an ablative landing gear. Abrasive would probably be the right way to say it. But yeah, see the pressure vessel right there? That's why. That's why you need a skid in the front. They don't have the space. See? There's a little skid plate. Yes, but how does the skid plate not shred itself into pieces? Does it have to be changed every time? Yes, it has to. Well, I mean, knowing them, they could probably get a couple of flights out of it. I don't know if it needs to be replaced every time. Actually, the skid plate could just be rubber. I mean, yeah, why wouldn't it be? It could just be rubber. In fact, I'll bet you it's probably that. It's probably rubber. Yeah. Here, you want to see a video of the drop test? The drop test is pretty rad. I don't know what it's made out of, S, because you want low so it doesn't ablate too fast. Frick if I know, dude. Also, there's a Global Hawk just sitting over there, by the way. Also Chinooks. Literally one of the most Chad helicopters ever designed by man. There we go. I love Chinooks, man. It's my favorite. Dude, remember when we studied the gearbox on how that thing actually works? And
we see a good lift. Nice job, 9 Charlie Hotel.
Nice job on the lift.
Release.
Oh, here it goes.
Deep dive.
Good flight controls. Copy. Good flight controls.
It's good. That doesn't have any engines. It doesn't make any noise. Oh, I'd ride on this, Geeson. That'd be sick.
Good radar altimeters.
Approach and land. VTIs.
Copy. Approach
I got
and
it,
land.
Kim.
VTIs are active.
No, it's doing it automatically, actually. Falling with style, that's right.
And the PTIs.
Copy. PTI is complete.
Don't fly into me. Yeah, Zero, isn't it cool?
400 feet.
So legit, dude. Speed brakes.
Gear. Copy, gear deploy.
That thing is so cool. Skirt.
Touchdown.
Oh.
How are the brakes?
You see the brakes? The brakes are making the wheels unhappy. Look at, you're getting some resonant, not some resonant, you're getting some vibrations from hitting the brakes. Watch the back left wheel.
Touchdown.
Watch. Hit the brakes. You might want to tweak that brake pressure. That's really cool. Yeah, the rudder working. Does it have ABS? Anti-locks? Probably. Maybe?
Go ahead and monitor your systems, guys. Monitor your systems.
Oh, that thing's gonna be so cool to see come down. No shoot, doesn't need it. It looks like the skid plate includes a thermal tile that disintegrates on contact. Yeah, granted, I saw that too.
Copy, gear deploy.
What will it launch on? We don't know yet. Actually, we do. No, it'll launch on Vulcan.
5 feet.
Yeah, it is. Yeah, it does. There is an abrasive tile right there. Interesting. I never noticed that.
How are the brakes?
The docking port is on the back, Shrubbery. The hatch is on top. It's over here. The hatch is on the very top. Still cool, though, man. And once again, we got a picture of the first one. Sierra posted a picture of the first flight prototype today. This one will be flying to the ISS. Yeah. That seems dangerous. What if it breaks off, then shoots back into the ship? It's got, like, the consistency of styrofoam. I wouldn't worry about it. And clearly they don't either, lols, because they're doing it that way, you know? Like, it's obviously not dangerous, because if it was dangerous, they wouldn't be doing it, you know? What if the tire shreds and hits the ship? Oh. Guys, well, C22, my question to you would be this. Well, what if the tire on an... Why is it not a concern when on an airplane, but it's a concern on this? Like, I don't understand. What remember what happened to Concorde? Yeah. Yeah, most planes, tires will explode when they hit something on the runway. Yeah, exactly, Switch. The shuttle tires never popped. We have 30 years experience of re-entry vehicles with tires on them. I mean, you'd think they would go raid the shuttle's documentation somewhere, right? Last, you missed the point on your statement. I'm saying the skid tire is... I'm saying the skid tire is 6 of 1/2 dozen of the other. Can this be manned? Yes. Darknaze, I do not see your last. Type it again, please. Yeah, okay. What are you looking at? Spaceship. How often did they change the shuttle's tires? Pretty often, Geeson. They didn't last very long. They didn't last very long because the shuttle's brakes, dude. They didn't... It's not that they didn't get the brakes right, but you had to be very... you had to be very careful with the shuttle's brakes to not cook them. And if you locked a tire and you flat-spotted one of the shuttle tires, well... Yeah, let's just say they're under a lot of pressure. I mean, you have 3 tires holding... Or, well... Yeah, 3 tires for the most part holding up 60 tons, dude. Yeah, they do need to be replaced. They did need to be replaced fairly often. Did you explain why there is a TFR for space operations in the Gulf tomorrow? No, I didn't know that there was, IQ. When you asked me it before, I said I don't know what you're talking about. Yeah. Oh, okay, Jordis. Yeah, I got you. Mm-hmm. No. Okay, C-22. Yeah, no, I just... Did the shuttle land especially fast? Junkyard had touched down at about 200 miles an hour and change. 320 kph. Dude, the shuttle's, like I said, 60 tons, man. It's coming in like a freight train. The reason why you had to touch down at that kind of crazy speed is because how I like to explain it is that the shuttle's really designed to, hang on. The shuttle is really designed to fly up there. It's not really designed to fly down here. It's only designed to fly down here just well enough to do this. Because once again, it's a glider, right? So they basically would nosedive this thing at the runway, right? Because that's the only way they could get the speed to flip this thing up and flare it and do that. And even then, yeah, you touch down at about 200 miles an hour, it can only do this for a second. If you screw this up, well, you're landing, just you might not land in the way that you want. The TFR is for Dragon 2 recovery for the CRS-22 mission. There you go, Thomas. Yeah, okay. I wasn't sure if they were recovering there in the Atlantic. Yeah, I know, C-22. Yep, it's pretty cool. I mean, the thing's coming in like a freight train because 200 miles an hour touchdown is the only way they could get this thing to basically zero out its vertical speed and fly without falling and sinking like a brick. What's that cloud on the wing for? Lift? Lift, T-Man. So the shuttle's wing. You know how the wing, you see how the wing has like a little bit of an armpit right here? Like, it's like this right here. Like if you look, the shuttle's wing looks like it goes out with the strake and then it goes out with the delta. There's a little bit of an armpit. Oops, sorry, I kicked my plate. At higher angles of attack, so like when the shuttle's coming in for landing, this armpit right here intentionally creates a vortex on the top of the wing. It intentionally creates low pressure over the wing, and the shuttle ends up generating a metric ton of lift. Well, not a metric ton. It's probably close to like 30 metric tons if you really want to know. You're generating insane amounts of lift right here, but you're also generating crazy amounts of drag by doing that. The vortex coming off the side of this wing is insane. Concorde actually does the same thing. Believe it or not, Concorde uses the exact same principle to land. And if you picture a Concorde or a Tu-144 landing in your mind, they have to tilt the nose down so the thing lands correctly. The thing is, yeah, somebody already said it. The thing is about in Florida, you have very high humidity. High humidity, it's very easy to see the effects going on here. Yeah, I'm sorry, the shuttle is insane. We never should have stopped flying it. I thought that it was so the pilots could see correctly. Yeah, what did I say? The droop nose is so the pilots could land at a high angle of attack, lulz. You said land correctly. Okay, nope. All right. Let's dispel all confusion right now before this turns into, well, you said this, well, you said this. Concorde needs to land at a high angle of attack. Its wings are intentionally designed with that same kind of armpit thing going on to create low pressure on the top of the wing at high angles of attack. Meaning if the more you nose it up, the more lift it's going to make. Okay? That's the only way the Concorde can land. If you tried to land it coming in like this, right, you're never going to stop in time. This is the only way it could land on a conventional runway. The British and French engineers that engineered this thing knew this. They needed to land at a high angle of attack to land correctly. The nose comes down so the pilots can see over the nose and see the runway, because you need a high angle of attack. Yes, it is because it lands correctly. The droop nose comes down so the pilots can see, because you have to land at a high angle of attack. Concorde doesn't land any other way. Yeah, I know, Xeon. I know. That's why I said let's just figure this out real quick. The shuttle, believe it or not, does the same exact thing. Same thing. You can see it in action right there. See? Why couldn't they use cameras? Phil, have you ever driven a car? I don't know. I don't know who I'm talking to. I don't know who's on the other end of this text. Have you ever driven a car? Do you want to drive a car with a camera on the front and no windshield? I don't want to do that. Nah, this isn't semantics this time around, Dish. It's just, yeah. The way EJ was talking makes it sound like the arrow was the reason for that. I actually think you're misunderstanding what I'm saying, but, I mean, hey, we clarified it, so it doesn't matter. Nah, I could manage. Pilots... So, one of the things about being a pilot is having good situational awareness. It doesn't matter if you're flying a Cessna or flying a 747 or a F-22, the space shuttle, it doesn't matter. You want situational awareness. You get better situational awareness by having a window. Plus, a window is a little bit less expensive to make than, you know, like a camera and a TV circuit and all this other... TV circuit? TV screen and all this other stuff. I don't want... A window has much... Okay, let me explain it this way. A window has much higher bandwidth of information than a camera would. Camera, you're limiting your field of view, right? Unless you had like a 3D camera or something, and I don't want that. I want to look out the window. And pilots want to look out the window. I've never met a pilot that ever said they would fly a plane. They would actually be on a plane that's flown by a camera. No. Maybe a drone, sure. But not an actual airplane. I wouldn't want to fly on an airplane where the only way you could see out the plane is with a camera. I wouldn't do that. A window is a lot more foolproof of a system, I think. And you can get much higher bandwidth of information. Your situational awareness is improved. A window also has higher FPS and refresh rate. Well, the bottleneck is always the Mark 1 eyeball, right? As Das would say. Yeah, I've seen it, Reagan. See that fairing split in half? Is the Valkyrie the same form of lifting body? No. The Valkyrie... Oh, dude. The Valkyrie is a little bit different. The XB-70, which is the gnarliest plane around... the XB-70 has a straight delta wing. Here, check this out. So the 70 uses something completely different, Junkyard. This is called... It's called compression lift. Dude, you want me to blow your friggin' mind? The 70 is insane. This thing, see that thing? It looks ridiculous. It looks like the lizard from Jurassic Park. It's Dotson here. Nobody cares. It reminds me of that, but doesn't matter. This thing could probably have gone way faster than the SR-71. I'd firmly believe that. It has canards, yeah, because... Here, let me explain. So, Junkyard, check the wing. No armpit, right? There's no armpit. There is something weird going on right here. See the line right there? Well, there's a reason for that, okay? The XB-70 took advantage of a phenomenon called compression lift, okay? So, when it's landing, you needed the canards, all right? It doesn't have the armpit wings. Actually, if you made an XB-70 with with a Concorde wing, it might be able to do it. But the XB-70 is a little bit weird in that when it's flying up in the air, the wings actually move down like this. See that? So when it's landing, the wings are straight, right? When you're actually flying around, the wings are down. There's a reason for this, okay? Now, and this is probably the reason why it doesn't have the armpit wing, right? So the technical way of saying that is a delta wing with a strake. The reason why is because, see that right there? That's the reason why the wings fold down. See that line, the intakes? right at the intakes, that's the reason. The XB70 uses a phenomenon called compression lift. So, when you're traveling at hypersonic speeds, okay, and hypersonic and supersonic, all right, the difference between these two is that when you're going hypersonic, what I'm about to say is actually on fire. Yeah, that's the difference. This thing right here cuts the air at hypersonic or at supersonic speeds. It cuts the air. And whenever you're going faster than the speed of sound, right, you leave a wake. Kind of like a boat. But not exactly. So this is an infrared image of T-38s breaking the sound barrier, or going faster than the sound barrier. You leave a wake. This thing is called a boundary layer. See that? And as you go faster, the angle of this boundary layer changes. It goes down, and it goes down here. Now, the XB70 doesn't have that armpit wing, but there's a reason why those wings fold down. Because when the XB70 reached a certain speed, that front intake piece channeled this boundary layer underneath the wings. It's a phenomenon called compression lift, like I said. It channeled that boundary layer underneath the wings and created insanely high pressure on the bottom of the wings at high altitude. Meaning that the XB70, when it gets up in the air, when it gets way up there, you don't need to turn the entire plane pitch up to fly correctly. When you're up there, the engines are actually doing a little bit of the work to keep you flying, and the wings are doing a lot of lift, but the air density up there is a lot thinner than it is down here, right? So it takes that boundary layer, right? The intake cuts the air and makes that boundary layer, and then it basically funnels it underneath the wings, and then the wings fold down. And once again, that makes the wings do generate like 3 or 4 times the amount of lift that they would at that altitude. So the plane can fly straight. And then those 6 engines that it has out back can be used to go fast. Yep. How come the Valkyrie doesn't have a droop nose? Well, with the Canards drummer, you don't need to land at a high angle of attack. You don't need to do it. I mean, an XB70 with Concorde wings would actually be a really, really, really dangerous plane. Like, dangerous in a good way. Yeah, the Canards make it so you don't need to do this. But once again, yeah, if the XB70 had Concorde's wings on it that could fold down, then, and a droop nose, well, that would be, yeah, that would be very, very fast. That would be a really fast plane. This was years before Concorde. The XB70 was the early 60s, if I'm remembering right. Yep. Yeah, it's the only plane that uses compression lift. This thing works more like a trimaran in the water, like a ship with 3 hulls. Trimarans do the same thing. Yeah, the Valkyrie is the only plane I know of that uses compression lift. I don't think anything else uses it. But, I mean, you need high pressure underneath the wings to generate lift. That's Bernoulli's principle, right? You need high pressure under the wings and low pressure over the top of the wings. The problem is when you're up there, it's really hard to get air compression underneath the wings because the air density is lower, right? So it's hard to get compressed air up there. So the Valkyrie, because of that compression lift, could fly at a really high altitude, and the wings, these wings that are bent down, basically generate as much lift as a wing that's 3 or 4 times the size of this. So you get a wing surface area that's way bigger than what the actual wing is. So once again, the engines could focus on going faster. They never tested this thing's top speed. Never did it. Canceled the program before that happened. They had a top speed. It did go fast during one of the tests, but they never went full speed. They never pushed it to its theoretical maximum. So this thing says its maximum speed is Mach 3.1, which is 2,200 miles an hour. I mean, it says 2,000 up there. I mean, Mach 3.1 is definitely higher than that, but it does, I mean, that does vary. It varies with altitude and temperature. But this thing, I bet you this thing could go faster than that. I bet you it could get up Mach 4, Mach 5. Yeah, I mean, you'd probably run it, you'd probably have to worry about it re-entering. You'd have to worry about shock heating, like the SR-71. That's the reason why they made the SR-71 out of titanium, for thermal protection. And even then, the SR-71 could probably go faster. I'll bet you it can. But yeah, Valkyries are insane, dude. Pretty cool. It's interesting that, you know, you have the Concorde, which is designed to do something completely different than the shuttle, have a very similar wing for the same freaking reasons, right? But the shuttle does something completely different, you know? The XB-70 doesn't have a droop snoop. It has a shield that comes up to go supersonic. Cool. That's pretty rad. Yuck, 76-month resub. Thank you. Does compression lift cause sonic booms? Yeah, of course. Remember, Sawyer, sonic boom is equivalent to airspeed. So it's airspeed. If the air traveling over the plane is going faster than the speed of sound, yeah, it's going to make a sonic boom. This is so amazing. You blew your mind. Coolest info I learned since I learned what a ramjet is. Yeah, it's pretty nuts, man. Bobby, nice. You're dangerous. But anyway, yeah, cool little dive into aerodynamics. It's fascinating stuff. But yeah, I mean, going back to it, that's why you have this vapor on the top here, because the air is going from high pressure to low pressure really fast. Junkyard, hold on. Now let's talk about the XF-85. that little freaking thing. Yeah, the bomber fighter jet. Yeah, dude, what a nutty idea. Cool, but really impractical, man. But yeah, I can see the link. But yeah, Junkyard linked the XF-85. Dude, that thing was so funny looking. Do you know if the XB-70 had the unstart issue that the Blackbird had? Not sure, Tylen. Not sure. That intake, though. That intake is cutting-edge stuff, even by today's standards. Dude, cutting the air and basically making an airplane into a trimaran. So, like a trimaran on a boat, right? You have outer pontoons and you have your center hull. A trimaran is supposed to do the same thing. All right? The reason why you have a trimaran hull is because the front, you have a bulbous bow that breaks the water, and the wake from the boat goes in between the main hull and the pontoon, right? And water is incompressible, right? So, at speed, the trimaran lifts itself up out of the water, and you get less hydrodynamic drag. An XB-70 does the exact same thing with air, but you have to be going a lot faster because water, a fluid, is incompressible, right? Liquids are incompressible to an extent. It really depends on what it is, but for the most part, you can't compress a liquid, right? And air is highly compressible. So the only way to get the XB-70 to do what a trimaran hull ship would do is to go really, really freaking fast. And that's why the XB-70 has 6 engines. Karmas, thanks to Iceman for your gifted sub. Right on, man. The Valkyrie versus the Vulcan? The Avro? The Vulcan is not... No. The Vulcan is... The Vulcan's a strategic bomber, and don't get me wrong, the XB-70 was supposed to be a strategic bomber as well, but the Vulcan needs all... It has big freaking Olympus 593 turbofans on it. It has 4 of them. They howl like crazy. But it needed those because the Vulcan was basically just carry as much bombs as you possibly can. So they needed bigger wings to hold up all those bombs, and they needed bigger engines to get those wings to generate lift. So just curious, how do you think the UFOs create lift with their shapes? I don't. And in terms of the Aurora spaceplane, somebody asked about that. The TR-3B, the Tic Tac, all those things. Yeah, I read about those things. I don't know. Look, man, if you have something that's capable of doing those maneuvers, you're obviously generating way more energy inside of that ship than we understand with conventional flight. So, yeah, I don't know, man. Aerodynamics, heck, if you could generate enough energy to be able to hover stably, freaking aerodynamics don't matter. That does not matter. You can just zip, bye-bye, you know. But anyway, let's keep going. So, of course, I Still Love You has arrived in the port of Long Beach and is being berthed at where the sea launch is being berthed in the port of Long Beach. Mighty Servant 1, which is a submersible dry dock ship, halfway sank itself, and of course I Still Love You was towed off of the Mighty Servant by a couple of tugs here in the port of Long Beach, and they berthed it in the inner harbor in Long Beach here. Check this out. So this is a SpaceX autonomous spaceport drone ship. It's used for landing Falcon 9s on it. They moved it out to Long Beach out on the west coast out here so it could catch rockets that are launching out of Vandenberg, which is over here. And they launched this way. So SpaceX a little while back leased this basically from here this way. SpaceX leased all of this for West Coast operations. Of course I Still Love You is berthed here. Oh, the photogrammetry updated. Now this is the former give it a second. The former Sea Launch berth here. Sea Launch is an oil rig that was converted to launch rockets into space. You see the launch pad right there? And this was supposed to carry the rocket out, carry and tow the oil rig. It was basically a submersible, basically, like I said, a launch tower, or a launch pad that you could tow anywhere in the ocean. The Russians bought it, and it's sitting in St. Peter's, Severomorsk. And then this berth was, this berth right here in the port of Long Beach was leased by SpaceX. So, of course, I Still Love You, Mighty Servant basically did what you see in this picture inside of the jetties at Long Beach. So that was somewhere right here, and then they towed the drone ship right there. Looking north, NRC Quest is docked to the left side, and of course I Still Love You is to the right side of the dock. So yeah, right there and right there. Cool. The shortfall of Gravitas is being built. It should be done sometime soon, Swishio. Wasn't Sea Launch self-propelled? Maybe. I don't know. I thought they towed it with the Commander, but I could be recalling that wrong. SpaceX formerly had a port. Their berth was over here. See this little parking lot right there? There's the NRC Quest right there. Right here. This little area was for SpaceX, and they had a Falcon 9 servicing port right here, so they could pull the thing off with the crane off of the drone ship. And if you look back at past pictures, right? This is before SpaceX leased this area. Oh yeah, there it is. There's just read the instructions. NRC Quest is right there. Just read the instructions. They moved it to the East Coast a little while back, and now they moved, of course, I Still Love You, the other drone ship, over here, back to the West Coast at their new berthing port, which is, once again, it's over here on the other side of Port of Long Beach. Long Beach is insane, by the way. If you like infrastructure, go drive around Long Beach. It's nuts. I wonder if there's still a backlog at the Port of Long Beach. Most likely. Yeah, look at all the imports coming into this place, dude. Unreal. It's crazy. It's crazy. It's ridiculous. Long Beach just goes on forever and ever and ever and ever and ever. If you look at it from here, let's see if we can go street view into like here. Check this out. It just looks like a city of freaking cranes. And they go on and on all the way to San Pedro, which is way over there. So you could just see San Pedro. Long Beach is ridiculous. Unloading the big box? Cool. I mean, Vulcans are sweet, Bobby. You know, I'll be honest with you. I like showing off my American stuff, right? But the Brits, at least at one point, knew how to engineer an airplane. There's some pretty insane stuff that came out of the UK. The Victory bombers are a good example of that. The de Havilland Mosquito, the Spitfire, obviously. The Lank. What else is on that list of ridiculous planes that they made? The de Havilland Comet, post-war. Hawker Hurricane, if you want to go back into World War II. There's the EEL. Ingersoll Electric Lightning is an insane aircraft. In a good way. When I say insane, I mean it in a good way. Frickin'... Dude, that list goes on and on. The Harrier is my favorite. The Harrier is my favorite British airplane. Maybe it's like up there. Well, Concorde's probably cooler, but that's French. Part French. So straight British plane. Harrier is insane. I like Lightnings. Lightnings are sweet because nothing beats going fast. Yeah, my favorite Cold War fighters are the MiG-21, the F-4 Phantom, and the EEL. What do all those planes have in common? Go fast. Go really fast. Did they have something as nutty as the Twin Mustang? Actually, Junkyard, the de Havilland Mosquito. Yeah. The Mosquito was nuts. So the de Havilland Mosquito is basically a twin Spitfire. So it has the two Merlin engines in it, right? The Mosquitoes were made out of they made them out of wood. So check this out. It's basically a twin Spitfire. There's two Spitfires with a fuselage here, and the plane's made out of wood. The power to weight is unreal. These things could outrun anything. That's one of my favorite planes from World War II by a long shot. That's right up there with the P-38, which is just... Alright. But that's Kelly Johnson, though, so... of course you make a plane better than everything else. Right? But the Mosquito is two Merlin engines. Two Merlin V-12s. And the plane's made out of wood. Nothing could go faster than this thing. This thing outran everything. Yeah, it's stealth, too, because it's wood. Wood doesn't bounce radar signals very well. This thing had the radar signature of a bird. Mosquitoes are my favorite, man. I love that thing. It's nothing beats speed. Germans can't shoot you down if they can't catch you. Yeah, mosquitoes are nuts, dude. Yeah, and they flew them low to just stay off radar completely. Geeson is right. These things went fast, man. Dude, I don't know if the 262 could catch one of these things. I don't know. What's this thing's top speed? Yeah, 400 miles an hour. Yeah, that's close. I don't know. Here, let's go. Let's check real quick while we're here. All right. The 262. So that's the first operational jet fighter, not the first jet. The Brits actually invented the turbojet as well, a guy by the name of Frank Whittle. But the Germans were the first one to build one into a fighter. What's the maximum speed? 560. So the Messerschmitt could catch it, but still, the fact that we're comparing a freaking piston, a V12 piston engine to a turbojet is insane. Like, the Mosquitoes can go pretty damn fast. It's almost comparable, which is okay. Only if the 262 got in the air quick enough. I'm kind of happy that it didn't, man, but I understand what you're saying. I'm pretty sure we didn't want that. Was the Lightning even faster? The English Electric Lightning? Oh yeah, way faster. The EEL can break Mach 2. It can go faster than 1,500 miles an hour. Not for very long, but... Oh, the P-38. Actually, now I'm curious. Let's look while we're here. .414. So the P-38 and the Mosquito are actually very comparable in terms of speed. Very comparable. These planes that have a cruising speed of 414 miles an hour, yeah, in a dive they could probably break the sound barrier, or at least skirt transonic. They could get close. Yeah, P-38s are insane. Just... Alright. How about the Twin Mustang? Twin Mustang never served in the war, but... Yeah, I mean, Twin Mustang could probably go really fast. Let's see, what else do we got here? Alright, so... Could the plane handle breaking the sound barrier? If it went past 1.1 Mach, or Mach 1, yeah, no, you'd have some really bad problems. Alright, let's see, what else do we got? So this one's coming from Mary, it's coming from Boca Chica Gal. Raptor RB5 is in the Raptor van, but so far has not been unloaded. We got another Raptor engine arriving at SpaceX's HQ down in... Well, not HQ, SpaceX's build site at Boca Chica. It's not working, B-Money. It's so small. So small, but that thing is one of the most powerful rocket engines ever devised. It's small, but it packs a big freaking punch, dude. Big punch. Raptor engines, for their size, the thrust that they can produce for the size is unbelievable. It's really, really ridiculous. It's like Raptor engines are like a twin turbo inline 4, or no, let's say like a twin turbo inline 6 if you're going to compare it to a rocket motor, or compare a rocket motor to a car motor. They're not the biggest. Inline 6s aren't the biggest, but they can make power. Raptors are quite literally like the 2JZ of freaking rocket motors. They're insane. They make ridiculous power for the size. Imagine if you sized it up. Nah, stuff doesn't scale very well. The rockets don't scale very well. If they did, we'd have rocket engines the size of Sea Dragon. Hey, beautiful. Wow. Okay. Interestingly enough, the new ones don't have the CH4 feed line installed. Right there, huh? What does that one pipe do? That's a pre-burner. It's incredible. Nothing like a jet. Yeah, I mean... Yeah, it's not like a jet because this is an impeller, Junkyard. This thing right here has more in common with a water pump on a car than it does with a turbocharger. Seriously, it's a fluid impeller. It's a fluid impeller. So this thing would be like if you had a turbocharger on a car. This thing's called a turbo pump. That's a CH4. It's a methane turbo pump, all right? Turbo pumps on rocket engines would be like if your fuel pump was attached to a turbo. So you have the turbine housing on a turbocharger. Take the compressor off and put the fuel pump there, or put a water pump there instead. And then have it move fuel instead of air. And then, because they're using liquid oxygen, you have one of those up here. You can't see it, but there's another turbo pump shaft. There's another power pack up here. It's behind all this stuff, but there's one for the oxidizer as well. That's what that is. It's a turbo pump, but it's a staged turbo pump. So what does that mean? These things, basically you have a turbo pump. So you have your turbine, and then you have an impeller, and it moves it. But some of the fuel gets ignited. And instead of like an intercooler charging, charging the air, or a turbocharger charging the air and an intercooler intercooling it, they actually heat it up. They preheat it. And they basically inject here through this pre-burner pipe. I think that's the pre-burner pipe, if I'm remembering. That one could be the pre-burner. I forget. They basically stage it, so they blow it up a little bit, so the turbo pump moves the methane and the liquid oxygen, right? Or the turbo pump moves the methane, and then they spray a little bit of liquid oxygen, and this thing outputs an extremely fuel-rich mixture. And then the oxidizer pump on the other side, right, outputs an extremely lean mixture. So this one is rich, the other one's lean, and then they combine those inside of the rocket engine and then blow it up. Staging it like that basically does the same thing that a turbocharger would do to a car. You can increase chamber pressure that way because you're getting a more efficient, amongst other things, you're getting a more efficient burn. And if you have a higher chamber pressure, you can make more thrust. The more stuff that you can explode inside of this at once, the more explosion comes out the bottom. Pretty straightforward stuff. Have you ever heard of the story of Taffy Holden's flight of the EEL XM135? Negative. Is that the engineer, Geeson, that took off by accident? Yeah, I remember this. Holden's Lightning flight. Dude, EELs are awesome, dude. What a cool plane. Oh, mate, we needed to go faster. We need to go faster, mate. Put another engine on top. Oh, sorry. Yep, no, just put another engine on it. Whatever. It's fine. Yep, the thing's... What initiates the burn? Can this start from still? So this thing has a spark igniter. So, Junkyard, you ever grill? You ever grill anything? Did you grill for the 4th of July if you're American? If your grill has an electric starter, literally that. Yeah, is this a torch igniter or a spark igniter, pray? I forget. Awesome, Geeson. So a torch igniter would be like lighting a grill off with a plumbing torch. It's basically the same thing. They're using sparks to ignite torches. Yeah, there you go. It's pretty crazy. So what they do to start these things up, Junkyard, is they thermally condition the engines. But thermally conditioning an engine, it gets all the cold stuff it gets all the fluids into it. It's basically priming it. They basically prime it. That's all. It's like that's the equivalent, rocket equivalent of priming is thermally conditioning an engine. They prime it, and then they basically flood the thing, right? And then a spark igniter ignites the flooded mixture, right? And then it turns on. This does not use T-tab. No. Spark igniters, you get better reuse. You get more reusability that way. You don't use triethyl aluminum and triethyl borane. No. Not with this. With the Merlins, though, yeah. They run the oxygen through the injectors, and then the flow rate for the fuel increases as it ignites. It's cool, man. But there would be no pump speed. What feeds fuel? Tank pressure. Tanks are pressurized. There are ways to spin it up. You could change. You could have a delta change in the tank pressure. But then again, if you spray ether down a carburetor's throat, what's it gonna do? Now, SpaceX's engines on Falcon 9 basically do the rocket equivalent of that. They spray ether down its throat, and that's how it starts. It's triethyl aluminum and triethyl borane, though. They're pyrophoric propellants. Yeah, rocket science gets difficult, dude. It gets tough. Yeah, they have pressurized tanks, and then Well, it's not a... I suppose it is a mechanical fuel pump, but like I said, it's a turbo pump. Rocket science is nuts, but it's the same stuff that you see with a car. It's just 1,000 times more freaking complicated, man. But yeah, this has combustion chamber pressure and stuff, and it has combustion chamber pressure just like a car would. You don't really necessarily have a compression ratio because you don't have a piston going up and down, but oh, that's cool, V-Money. How'd you get a model of that? Nice, C-22. Rockets are sick, dude. That's why I love it, dude. That's why I do what I do here. I teach people about this stuff. This is called a staged combustion cycle. It's insane. A full flow staged combustion cycle. Once again, Raptors might not be big, but they pack a punch. Just like how an inline 6 is not going to have like an RB26 or a 2JZ in a Supra. Is that a Supra? Is that a Supra? It's not gonna be as big or have as high of a displacement as like a V8 or an LS engine, right? But the turbos make up for that. Yeah, full flow stage combustion is like twin turboing it. Yeah, that's a good way to say that. Yeah, so these things don't look very big, but they pack a punch. Seriously, that's real cutting edge stuff. Your dad was the VP of Sea Launch? Why have you never told me this before? You have? Why did I not remember this, B? What? You can answer all your questions. I mean, I don't have any questions. I think sea launch is a good idea. Imagine launching stuff from an oil rig. Pretty good concept, right? You've been on the boats, too? You're old? Shut up. You shut your mouth. Be quiet. Yeah, it's kind of like rocket engines junkyard are like jet engines on crack. Yeah, that's the right way to say that. Actually, junkyard, you know what I want to do? Dude, I want to go messing with a car engine and take a turbine from like on a turbocharger, go find a junkyard turbo, put it on an engine, right? And see if I can deliver the fuel. Take the compressor housing off, right? And then cut the turbo shaft on the turbocharger and attach it to a water pump or a fluid impeller and see if I could get an engine to run off a turbine-delivered fuel pump. Like, see if I can get an engine to run off of a turbo pump. It would be the dumbest thing, dude, but it'd be so freaking cool. Oh, yeah. Yeah, that's right. Yeah, no. Fuel rails? No. Electronic fuel pump? No. Mechanical fuel pump? Hell no. No. We have a turbo pump feeding this. I'd love to do it, dude. It'd be so stupid. That would be so dumb, but it'd be amazing. Oh my god. How ridiculous would that actually be? I mean, it's doable. I don't know what's going to happen when the turbo spools, though. That could end very poorly. The immediate thing that pops into my head, junkyard, is head gasket. Actually, no. You know what? It wouldn't. No. You'd roll coal. You'd run extremely fuel rich when the turbo spools. You'd run extremely fuel rich with the turbo. You'd make a lot of power. How about an engine, right? Take like an LS engine, all right? And you have your turbo pump on one side and a turbocharger on the other side. I don't know why you would do that, but you know what? It doesn't matter. The gas mileage, though. Yeah, as the turbo spools, the gas mileage would go. There's a fine line between clever and stupid. I'm pretty sure this one goes into the stupid category, Jack, but you know what? I can't figure out a good enough reason to not do it. I see a fuel mixture ratio of 1 to 1. Yeah, I think we'd flood the motor, Max. The motor would be like... I kind of want to try it. It's so stupid. It's such a stupid idea. Oh my god. But I actually think it'd be fun, man. We should do it. Liquid oxygen on one side and fuel on the other? Yeah. Head gasket. You'd be visiting Rodney real quick, man. What if you turbo the fuel and the air? So, S, what are we talking about here? We're talking about a turbocharger. A turbocharger that... Why am I entertaining this idea? All right, so let's think about this. You have your engine, you have your intake. Well, how are we staging this? How are we staging this? Do we have turbocharger and then fuel, or do you have... No, it would have to be injected, so they'd have to meet in a Y pipe, right? So the turbocharger through an intercooler, right? Turbo pump, basically from the fuel tank into the turbo, right? Or into the impeller. And then we'd have to find a way for it to atomize to go in. We'd have to find a way to basically carburetor the thing. I'm pretty damn sure that we don't need that big of... Yeah, I'm pretty sure that we need to find the smallest turbo we possibly can. Because of stoichiometry, that impeller would need to be nothing. It would need to be very, very small. Geared turbo for fuel and air. Oh, so we're gonna RL10 this thing? Okay. Actually, that's a good idea, man. Can we do this? Can you imagine? You have a turbocharger, and the turbocharger's going into a gearbox for your fuel pump. It's such a stupid idea. It's so dumb. But I like it. I can't think of a reason to not do that. Would this work for a ship diesel engine? I don't think you need to do this. This is not a good idea. Like, an electronic fuel pump can deliver the fuel fast enough. Expander cycle. Dude, and then after that, if we post-compression, if we found a way to preheat it, we could stage it like a Skyactiv, like Mazda's Skyactiv. That would actually really increase combustion efficiency, right? Yeah. This is a recipe for a runaway engine. Bring it. Yeah, Junkyard, we'd need a wastegate return line for the turbo pump. Yeah, you'd need a wastegate return line. How would you do that with... Yeah, your wastegate would need to move liquid back to the gas tank. That's actually really cool. Gas tank would get foamy. It would get something, of course. Ah, live fan fiction engineering at its finest. Yeah, but Bobby, what if I'm actually smart enough to go and do this? Regulator post the injection, residual pressure would bleed back. Dude, it'd be freaking... Junkyard, this would be the most useless thing, but god dang would it be cool! Yeah, starting it would be a little weird, but then again, an internal combustion engine, as long as you can move the air, right, to start the turbine, an engine would work just fine. Would the turbo pump prevent good exhaust flow, though? I mean, pumping the fuel would slow the impeller. See, the problem is that, yeah, you'd get spool. So you would need a turbo that spools at a linear rate compared to the engine. So, like, if the engine is at 800 RPM, the turbo would need to be at whatever the turbo pump would need to be at whatever equivalent amount of fuel that you'd consume at 800 RPM. So let's just say it's 1-to-1, just to make the engineering easier, right? If the engine is at 800 revolutions per minute, the turbo would need to be at 800 RPM, and the impeller would need to deliver however much fuel you would need at the equivalent, right? And then if you rev the engine up, the problem is that thing is going to spool. You basically want the turbo spooled when the engine is even at idle. And then if the motor goes up to 5,000 RPM, the turbo needs to basically spool linearly with the engine. That's hard. It's not hard to do. It's just, yeah. I mean, Leroy, you'd have to do it in a way that would rob power, because you'd have to impinge the exhaust to get it to spool at low revs, right? Am I thinking about that correctly? You just get rid of the middleman here and put a gas turbine in the truck. I agree. Yeah, no, I don't disagree. Find me a gas turbine. Let's find a gas turbine, Max. I'd do it. Oh, I'd do it. Yeah, I would do it real quick. I'd love gas turbines. They're my favorite. Tuning nightmare. Really, Hellfish, it is. Yeah, because you have a mechanical spooled freaking pump. Now, I mean, it's really rocket science. I'll bet you, Hellfish, that's the reason why nobody does this. Because it's insane. It's ridiculously complicated. There's simpler ways to do it. But it could work. Is fuel consumption of engines linear to RPM? Well, you have to, Altio, yeah, you'd want to maintain stoichiometric fuel ratio throughout all RPMs. That's what tuning a motor does. Do it. You won't. No balls. How much is it? And how much power does it make? It's a gas turbine AB1520T. It's $5,000, dude. What's the shaft horsepower? Nah, it's not gonna work. Imagine the gearbox required. Came here, as long as it's into a fluid coupling, a torque converter with a high stall speed, you'd be fine. Sure. It would creep like a mother when you put it in drive. Ooh. Yeah, I would not want a manual transmission with that. You'd go to bite the clutch and the jet engine would just burn the clutch immediately because of the high RPMs. Yeah, you'd need a torque converter to get that to work correctly. It would have to be to an automatic transmission. How's this? Are we doing this? A Garrett GTCP 182 gas turbine. So that's an APU. Oh, man. That's too big, dude. I don't think that would fit. I seriously don't think that would fit in the truck. It's a military-issue gas turbine APU. It's in running condition as a functional control interface. It's mounted with a 3-point mount. Engine is designed to provide bleed air, shaft power, or a combination of the two. Bleed air. It is electrically autonomous and started via 24 volts. Well, there's a problem right off the bat. Cars are 12 volt systems. You'd need a transformer for that to get it to work, right? I mean, how much is this thing on eBay? How much is it? It's 10 G's. It's expensive, dude. Or just another battery. 2 batteries in series, yeah. Yeah, the turbine Indy car. That's all-wheel drive. Yeah, Jared, that thing was cool. Is this the BE4 that ULA would be using? No. Soapbox, no. Ignore. Did you see my link? No, serious. What's that? I won't. What will I not? Oh, God. See, that's a turbojet. That's not a gas turbine, man. That's thrust, not shaft horsepower. That's that's death. That's death, dude. Just buy this. Turbine powered 2018 turns turbine street rail. What is this using? It's a Boeing 250 BO-8A gas turbine helicopter engine, factory rated at 300 horsepower. Let me take a look. Yeah, Hellfish. Mm-hmm. Gas turbine powers an electric motor instead? Yeah, King Kitten, of course that would work. In fact, whoever in the Chevy Volt did something like that. King Kitten. The Chevy Volt had basically a little lawnmower engine that was turning an alternator. And the funny thing is that the Chevy Volt got better. It gets better fuel economy than a Tesla. A Tesla gets about 100 mpge, which is mpge is basically taking like the amount of energy that like a full charge of batteries, like basically the equivalent. Like how much gasoline would you need to generate that much power, right? The Chevy Volt got like 130 miles to the gallon, something like that, and that was with an internal combustion engine. If you had a turbine electric car, and you had a jet engine spin an alternator, right? Even a jet engine through a reduction gear spinning an alternator, that would actually you'd want to speed up. No, 1-to-1 would be fine. If you had a gas turbine that's turning an alternator, it would be insane. You could generate crazy amounts of power, crazy amounts of electricity in this regard. The first TGV was turbine electric. Cool. How efficient is a jet engine? Jet engines. So the thing about jet engines, Junkyard, is that they need basically the same amount of fuel no matter what speed they're at. So, like it's more complicated than that. It always is, and I know this. So a jet engine needs basically the same amount of fuel to run at low RPMs as it does at high RPMs, right? For the most part. So when they're not spooled, they're very inefficient. Very inefficient. Just... the thing is, it's a little more complicated than that. It's not like you're spraying the same amount of fuel no matter what the RPM. It's just they really like high RPMs. They stay very efficient up there. Go knock on the Pentagon's door? Just go to a government auction. A Lycoming T-53 would be fine. How much do those things cost? These things create 500 horsepower. Pressure ratio 6-to-1. In ideal conditions, how efficient? Well, pretty damn efficient. They're better. They're better than gasoline motors at high RPMs. Have you seen the video where the Russian guy put a MiG APU into a BMW? No, but that's really cool. I don't know the exact efficiency. It really depends. Yeah, that wouldn't fit. That would not fit inside of the car. Any car. Problem with the turbine electric is you still end up with an intermediate battery system, and it's more mass efficient to just charge the car from a grid. At larger scale, like a semi-truck, constant charging from a small turbine would make more sense. Yeah, I mean, but see, Prey, this is just the standard engineering kind of working your way through. At that scale, you might as well use a fuel cell. Fuel cell would be way better than a turbine, right? Dude, if I could get my hands on one of these things, I'd need to have some people help me make some, like... I'd need to have people help me engineer this thing, but we could do it. I found a T-53. It's $157,000. What about Jay Leno's turbine car? That's a Well, that's a specialized gas turbine, Sirius. That's the thing. The turbine car that Chrysler engineered, they engineered it from the ground up, including the turbine. The turbine is a Chrysler turbine. And it has... Yeah, the way they have it set up is way different than a gas turbine. It was basically a gas turbine that's specially designed to go in a car. Speaking of electric, Dodge is going to make an electric muscle car coming in 2024. Cool. It's easier to get gasoline than hydrogen. True story. A Williams F-107 would work. Yeah, but it's a turbofan, dude. It's not a gas turbine. We need gas turbines. Are gas turbines street legal? Sure. Why not? Why wouldn't they be? Rolls-Royce M250. Oh, it's an Allison, okay. What's the specs on this thing? 300 horsepower? Here's the perfect engine. Oh, funny, that's exactly what I'm looking at here. 3,500 bucks, huh? I'm not gonna lie, if we did this, I would need help, and I would need a shop to get it done. I can't do this kind of fabrication in my freaking garage, dude. But I would love to. I'd love to do it. That would be amazing. Yeah, Max, there we go. Wait, what are we looking at there? That's not a... Is that a gas turbine? How's that a gas turbine? The pictures are a diesel motor. See last. I mean this one, EcoJet. Huh. Oh. See, we need to find the right turbo shaft. Well, Prey, I would use something off the shelf, honestly. I would use off the shelf. We would have to use an APU or a helicopter engine, and those are expensive, right? But... And we'd have to find probably... We'd have to get one of the frickin'... We'd have to get one of the beefiest automatic transmissions we can find, because there's no way we're putting a manual on that thing. I can already tell you right now, you'd put the clutch in, and you'd shift it, and you'd dump the clutch, and the turbine would stall. You'd get compressor stall. There's no way that you wouldn't. It needs to be a fluid coupling. Expandable clutch discs. Last. The cheapest thing I found is the bill if you strip the generator off of it. Helicopter turbines are too expensive. Yep. Man, this Space News went on a pretty hard tangent. Just buy a shop with an attached garage. Yep. A really high final drive? No, you... Actually, S, if I was going to do this, I wouldn't want it to make power. I would... Honestly, the first thing that I would want to do is just make something that works, to be honest with you. Koenigsegg hydrocoupler direct drive. That's called the torque converter, man. I just learned of this in my area, and they say future possibility in Boston. What's that? The Enclave. What are these? What is this? What is Merkers? What is this? I don't understand. Auto complex. Okay. Yeah, Prey. The ZF-10 speed actually could probably. That's not a bad idea. I mean, dude, this is basically getting into aerospace engineering at this point, but. With multiple tracks and garage retail space. Oh, cool. You need to keep the turbine on a constant high load or it will overspeed. Yeah, that's why a fluid coupling probably is the right move, Prey. I mean, that's what Chrysler did. You have to do it that way or else it doesn't work correctly.
Discovery, go at throttle.
Caligulard, 65-month resub. 200 acres, about 10 minutes from my house. What? So, like, is this 300 private garages, 1.6 mile Tilke design performance circuit, 80 acre off-road experience. So this is just, you go buy garage space and that's it? Huh. Well, this would work. An M250. Yeah, that's what was linked a couple of times, dude. We would need to convert it to run off diesel fuel, not JP4. But yeah, just on a side note, I mean, it's aviation, it's kerosene. Basically, it's freaking using RP1. JP4 is a 50-50 kerosene gasoline blend. Oh. Huh. Yeah, Mercus, I agree. Very high-end garage space can be used for functions and whatnot. Interesting. Anyway, let's get back going here. We got some news with Hubble. Yeah, serious. Well, it's gonna take a little bit of investment, and I would need some place to build it that's, you know, not my parents' garage. Anyway, NASA successfully completed a test of procedures that would be used to switch to backup hardware on Hubble in response to the payload computer problem. The switch could occur next week after further preparations. Okay. They're going to try to switch to the backup computer to get Hubble back online. Hubble's scientific instruments package basically crapped the bed the other day. Interesting. Alright, let's see what else we got. So this is coming from Gavin here. Let's see, what's Gavin saying? Dragon recovery ship Go Navigator is outbound from Tampa for the CRS-22 splashdown. Splashdown is set for Friday at 11:30 p.m. ET. Yeah, the CRS-22 Dragon capsule undocked from the space station this morning, and it will be down tomorrow afternoon. It's been up there how long? 1990? Yeah, Leroy, yeah, it kind of does, right? They'd be pissed. Yeah, it's been up there for a while, Wefferl. The FAA space... What is this? The FAA Space Data Integrator is a game changer. It tells us where a rocket is in near real time so we can keep your flight moving safely during a space launch. Wait a minute. Wait a minute, wait a minute. Yeah, Livid, that's fine. That's fan made that. It's pretty cool. SDI, in combination with other tools, allows us to safely reopen the airspace quicker and reduce the number of aircraft affected by launch or reentry. Well, no, guys, this type of technology comes from them consolidating the rules, or not consolidating the rules. That's not the right way to say it. Basically, what was it? I think it's Space Policy Directive 3 or 4. That that came out, what is that, like 2018 or something? One of the space policy directives basically redirected the FAA to, instead of like having the range and the NOAA and the FCC and everybody else coordinate with the FAA to launch, they didn't deregulate. They consolidated all the places that you needed to go to be able to launch something into space. And basically, long story short, they made it so launching a rocket is similar to like launching a plane. They didn't make launching stuff into space easier, but the FAA is now like the one-stop shop for launching stuff into space. And the Space Data Integrator basically is it's the integrator, operative word there. They're integrating rocket flights in with regular air traffic, which is smart. So, in the future, you could, you know, like launch a Starship Earth to Earth, and yeah, it wouldn't be any problems. Yeah, that's one of the reasons why they optimized it, because space, the market for space is expanding like crazy, actually. So, I mean, it's easier to launch things into space nowadays because the FAA is like your one-stop shop. So they basically made it so they can track rockets like they could track planes in near real time. That's actually really cool. I'd love to look at that thing. Here, let's check the press release. Government being smart and productive? Weird. Yeah. Look. As much as everybody wants to dump on the FAA and every other government organization, right? The FAA actually has their crap together. I said this once, I'll say it again. The FAA does have their crap together. They really do. The reason why is because the FAA's regulations are basically at the whim of the commercial airline industry. Or, I mean, I guess the way to look at that is vice versa. But the thing is that in order for the airline industry to stay profitable, they got to keep going. The industry will collapse if they were hampered by a lot of bureaucracy, right? So the FAA actually does go fast. I've said it once, I'll say it again. If you cast your mind back a little earlier this year, when everybody was getting up the FAA's tailpipe about them not certifying Starship flights to go, and WNHOP is delayed by a week because the FAA is inefficient. No, it's quite literally the opposite of that. The fact that they're even willing to do this and release the licenses to do rapid prototype testing with Starship is insane. Anybody that knows a little bit about how the FAA operates know that they don't play games like that. The FAA actually is useful and they get stuff done. And they made the airline industry 1,000 times freaking safer. That's one of the reasons why it's so safe to fly, is because of the FAA. Pretty cool. That's awesome that they'll be able to track it like a center. Like, oh yeah, low Earth orbit center. This is Starship. United Airlines Starship Flight 154. Don't call it that. You know, requesting permission for entry and landing for EDL at Tokyo Airport, Tokyo Spaceport. Right? Like, that's cool, man. That's pretty awesome. 153. Yeah, we'll go with 153. That's pretty cool, man. Space ATCs, dude. This is, I'll be honest with you, that's basically laying the groundwork for that. This is basically laying the groundwork for that one day. This is Starship Mars Colonial Transporter 257 inbound from Mars on a trans-Earth injection, requesting permission to land at Boston Spaceport. Yeah, this is, you know, Boston Spaceport. Starship Mars Colonial Transporter, you're cleared to land on oil rig 3 there in the Boston Spaceport, guy. Like, yeah, that could happen. This is paving the groundwork for that. You know, it's a joke, right? Kidding. But also, at the same time, they never have that much accent. You shut your mouth. Go around. Nope. Nope. Attention passengers, if you look out the left window here, you will see the entirety of Earth. Yeah, I hope you enjoy it. We're about to land down there. Go around. Well, the reason why the reason why they have the data integrator, right, is because you can't really stop the rocket. There's no getting back up into space once you're on an entry. That's pretty much it. That's why there's a hazard area. I'm gonna have to put it in the Hudson. You don't really want that. Tiles on aero cover. What is this? Nice. 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 16 is not gonna hop. It's a museum piece. There you go. Wow, they really changed the mechanism for lifting, huh? What the heck? Okay. LA speed check 2.0, yeah, right? 16 never hopped. 15 was the last Starship that flew. That's... Why would you lift this like this? I'm confused. Why is it on a lever arm and why is it allowed lateral movement like that? We're gonna have to put it in the LA River! Oh, God. Not that crock of crap again. Oh, God, my computers are malfunctioning. We're 100 miles where we shouldn't be. Never mind looking out the goddamn window. No, we can't land at LAX. No, we can't land at Long Beach. All have runways that are reasonably long enough. No. LA River. Yeah. Screw that movie, man. Screw that movie. It's not like, oh, geez, there's not like there's, runways. It's not like Palmdale is a hop, skip, and a jump away when you're going Mach 5. No. The river. Who wrote this? It looks like they could lift it in an upright position without the hard points through the TPS on the windward side. Yeah, that's really interesting, Prey. The fabrication looks like crap. Why are there all ripples in the panel? It's because it's stainless, dude. We're not used to seeing stainless steel rockets, and they make this stuff outside, dude. Trust me, it'll look like a spaceship when it's done. SpaceX is very, just send it with their engineering, dude. That's just kind of how they roll, bro. That's cool, though, Thomas. Yeah, the stainless is what makes it all bumpy like that. They're using 4mm 304L stainless. Yeah, the core. Yeah. Interesting. So, Junkyard, what SpaceX is trying to do is they're trying to mass produce starships. That's really what they're scaling to do.
Discovery,
in that you see a lot of rapid prototyping. Basically, think like if you were playing like Factorio or something. There's a lot of just make another one, just make another one, just make another one, because it's stainless steel. It's not like they're using Inconel or titanium or aluminum or anything. No, it's just stainless. And well, it is kind of a pain in the butt to fabricate with stainless, but I mean, you just make another one, just make another one, just make another one. Dude, they're cranking out nose cones left and right. And I mean, comparatively, you should have seen the first one. The first one that they cranked out looked like it was about to deflate. We're going to find out if the turbulence it produces when supersonic will be significant when it launches. Yeah, right? Hey, Diraj, 42 month resub. 42, nice. And then Rocketology with the raid. What's going on, man? Narf! What's up, dude? You guys know my buddy Rocketology. Fellow Kerbal streamer. Might be a little bit too obsessed with mods. I don't know. He should be kind of weird. I don't know if we should trust him. Yeah. Yeah, the freaking, yeah. I remember that. Remember when we all thought that was it, Thomas? Like, hey, I was doing mostly stock today. I actually saved the pod, mostly. Hey, Rocket, we should play squad, dude. I know you said you had Arma. I'll buy you squad. I don't care. I'll buy you squad for America's birthday. That's how that works, right? Sure, why not? For the 4th, you'll get a 4th of July present. We'll play squad together, dude. Trust me, you'd like squad. If you try to run and gun when you play squad, yeah, that doesn't work. Yeah, that doesn't work. Yeah, try to run and gun. You won't last. I mean, Rocketology, let's just put it this way. Last time I was playing squad with the community, right? We were all sitting on a hedgerow, not a hedgerow, but a wall in a poppy field in because one of the levels was Afghanistan, right? And one of the guys is like, no, I got this, I can get him. Pops out, clapped instantly. Oh yeah, you'll get popped if you stick your head out at the wrong time. And it's 1 to 2 shots. 1 to 2 shots will put somebody down. And then there's suppression fire mechanics too. If you're being suppressed, your screen goes blank. Yeah. So there's suppression mechanics as well. So you can get a guy up with a 249 just going, and he'll cover your movement, just like how it works in real life. Yeah, you'd like squad, dude. It's fun. Really fun game. If you don't work as a team, you will lose very badly. Yeah, it's really cool. Yeah, no, I'll buy, Rocket, I will buy you squad and we will play squad on stream sometime, dude. Squad is like Arma for people who like Call of Duty. Yeah, no. More like Squad is a game, where you actually shoot and it doesn't feel like you're shooting a Tinker Toy. Yeah, that's what Squad is. Every time I play Arma, the mechanics of it, the gun mechanics feel like you're shooting a freaking like pop gun or something. It's so clunky. How can you guys like that? It's terrible. Pad is being cleared for Booster 3 testing. Cool. Yeah, we'll play, dude. No, we'll play squad, and you trust me, you'll be able to play squad, and you could jump right in, and you'll be like, oh, this makes sense, It's clunky, but the clunk gives it character. More like makes it bad. Squad, you actually connect with people. If you hit someone, they're going down. The huge missions and combined ops are cool. But yeah, so like, squad is like Battlefield-sized maps. Maybe a little bit bigger. Yeah. But once again, yeah, they're about Battlefield-sized maps. They're not like the huge things that Arma is, right? But it's good enough to, trust me, it's good enough to get the point across. Alright, anyway. Next bit of space news. So Landsat 9 has arrived at Vandenberg in preparations for launch. Landsat 9 is an Earth observation satellite, and we saw its Atlas core get moved to Vandenberg the other day via an airplane. Landsat 9, once again, Earth observation satellite, will be launching on an Atlas out of Slick 3. Satellite was made by Northrop Grumman. Cool. And check that out. Look at this. Yeah, baby. I can't stand the clunk in Armor Prey. I hate it. It's terrible. That's great. You can do full-scale operations. I don't care. If I go to shoot the guy, I want him to... And I hit him, I want him to fall over. Yep, they move around an Atlas core stage in the Antonov. Why aren't they launching this on Antares? Antares has no West Coast launch site, Livid. And... that's not how it do. That's a big friggin' plane, dude. Antonovs are so ridiculously big, there's a gantry crane built in. Seriously, a gantry crane. So if you need to pick stuff up out of the cargo bay and like drop it out the back, yeah, there's a gantry crane built into the vehicle. These Antonov 124s are made by the Antonov Design Bureau. They were made for the Soviet Union for moving tanks. The U.S. equivalent would be a C-5. The C-5 is a plane of similar capacity. And if anybody's seen a C-5, you know how big those things are. They're freaking gigantic. I mean, look at the people. Look at the people walking into C-5. It's nuts. Antares is advertised as being able to launch from the West Coast, though. So you tell me, Thomas, why aren't they launching it on Antares then? You tell me. Come on. I'll wait. I'll wait. Why aren't we launching Landsat 9 on Antares? Anytime. Because Atlas is Chad tier. Alright. Yep. I just lost a little bit of respect for you. No. You're not one of the Semanto people. Stop it. Stop doing that. Stop it. Stop it. Stop it. Anyway. Let's keep going. So, first, Astranus satellite in the final phase of assembly. What is this? This is coming from Space News. It's coming from Jeff Faust. I don't even know what Astranus is. Astranus announced that its first line of very small geostationary orbit satellites is entering its final phase of assembly for launch in early 2022. San Francisco-based company said July 8th that the communications payload for the satellite it built for Pacific Data Port Incorporated, called Arcturus, passed an end-to-end test that shows it's exceeded its expected performance. That allows the company to move into the final phases of assembly of the satellite to launch in early 2022 on a Falcon 9. The satellite is the first in line of micro-geo satellites weighing 400 kilograms each. Astranus is developing. The company raised $250 million Series C funding round on April 14th. That valued the company at $1.4 billion and has raised more than $350 million to date. PDI plans to use Arcturus as part of a project called Aurora to provide rural broadband services in Alaska. We know Astranus is working around the clock to ensure that this program is a resounding success, and it's inspiring to see a strong concerted effort focused on a state traditionally overlooked by the major satellite players. That's interesting. So, it's an internet satellite constellation out of GEO. I wonder what type of technology they have to be able to overcome the lag problems from geostationary satellites. Because, so if you have something like Starlink, like what SpaceX has, or Project Kuiper, or OneWeb, or something, right? Those satellites are in low Earth orbit. They're a lot closer to Earth. Literally, ping. You can ping the satellites very quickly because they're only the maximum like is like 300-400 miles that way, right? Not bad. Geostationary satellites and geostationary internet has traditionally had a problem where, oh, I don't know, it's 23,000 miles that way. So you get very bad lag with those things. I wonder what Astranis came up with to overcome that ping problem. Interesting, because I mean, clearly it's enough for somebody to invest $250 million into the company. The company evaluated at $1.4 billion. Clearly, there's some kind of tech here that I don't understand. Really fast radio waves. Well, at that point, I mean, like optical, maybe. Maybe it's optical. Who knows? I mean, I don't know how you'd do that correctly because Earth's atmosphere and stuff, but interesting. Might be the first Falcon 9 direct geo mission. Cool. There's no technology that could decrease latency to geo, period. Yeah, unless we have like quantum tunneling internet satellites, right? Like, I wonder. Interesting. Anyway, there's another one coming from Space News here. This is coming from Jeff Faust. Let's see. Supply chain Artemis program limit SLS use for science missions. Uh-oh. I mean, lasers could increase bandwidth, I suppose, right? But yeah, no, you're right. Washington, a limited supply chain and the demands of the Artemis program will prevent the use of the Space Launch System for alternative roles, such as launching science missions, until at least late this decade. In a briefing about the SLS to the Steering Committee of Planetary Science Decadal Survey on July 7th, Robert Stowe of Marshall Space Flight Center said that if scientists are contemplating missions that require the use of SLS, they should be talking with NASA now to secure manifest slots no earlier than the late 2020s or early 2030s. Given the demands of the Artemis program between now and the late 2020s, he said, it's going to be very difficult to squeeze a science mission in that time frame. Well, NASA has a goal of being able to launch 3 SLS missions in a 24-month time period and 2 in 12 months. The supply chain is currently limited to 1 SLS per year. That will change by the early 2030s, he said, growing to 2 per year, thus creating opportunities for additional SLS missions beyond the Artemis program. That will be enabled by changes at the Michoud assembly facility to increase core stage production, and a block upgrade to the RS-25 engine used on the core stage will be cheaper and faster to produce. NASA also expects to shift to the Block 2 versions of SLS by the late 2020s. The Block 2 will be based on the Block 1B version, with the larger exploration upper stage to be introduced on the 4th SLS mission, but will replace the existing 5-segment solid rocket boosters with a new design that will further increase the vehicle's performance. Performance of SLS is of interest to scientists proposing missions to the outer solar system in particular. SLS Block 2 will be able to send payloads of nearly 10 tons directly to Jupiter and nearly as much to Saturn with a Jupiter gravity assist. The use of additional stages, such as versions of Centaur, can double that payload as well as enable direct missions to Uranus and Neptune. Well, the manifest for SLS is not fully established for the 2030s or the late 2020s. I would say right now is the optimal time to engage with Human Exploration Operations Mission Directorate to make sure that these missions get on the docket. That may be difficult since it's not clear what missions NASA will pursue that would require or could benefit from an SLS launch. The ongoing Planetary Science Decadal, which will provide recommendations on the highest priority missions for the next decade, won't be completed until the spring of 2022. As for his estimate for estimates on SLS costs, he said that we are close to $1 billion per launch right now, and projected that to decrease by 20 to 30% by the early 2030s as flight rate increases. Keep in mind that $1 billion per launch is total cost involved, literally going from nothing to a full rocket launch. Something that really no other rocket is judged by those metrics. Only NASA is, because they have to be forthcoming about how they spend their money, so you get your total cost involved. Well, based on that article, the supply chain issue is on NASA, since they have yet to tell Boeing they want more than one core in EUS per year. It includes R&D, tooling, infrastructure, jobs, electricity, the electrical bills, HVAC, everything. Floating something that everybody needs to understand, and I say this a lot, but it's good to repeat. It's total cost involved. Any facility that's a NASA facility that uses SLS has to foot the SLS program has to foot the maintenance bill. So part of the $1 billion per launch is maintaining the VAB when it's not being used to launch things. The VAB maintenance bill, right? 39B, the maintenance bill on the pad. That's what I mean. Total cost involved. The only way you bring the price down with TCI is launching more, like what he said. Which is why I've always said that SLS launching once per year is the dumbest thing I've ever heard. But, hey, it is what it is. I mean, this is $30 billion. That's the reason why we're seeing the reeling effects of canceling Constellation. This is one of them. Yep, there you go. I'm not going to go into detail. Hey, Demos, welcome back. How much does SLS cost if you factor it like Space does? Like SpaceX does? So, SpaceX's price, basically, for the launch operations and manufacture of the rocket. That's basically it. Manufacture and launch operations. If you did that with SLS, I don't know, 400, 500 million maybe? I'd say about 500 million. That's an estimate, though. I'm pulling that out of my tail. If you priced how NASA budgets launches with how SpaceX does it, yeah, it's about 400 or 500 million, somewhere around there. Yeah. I can say that with pretty damn good confidence. If you gauge the shuttle by that same thing, heck, it's less than that. It's 200, 300 million. Yeah, I mean the last price that was quoted for the shuttle program was what, 450 million for a shuttle launch? That 450 million is total cost involved. So if you launch the shuttle at cost, right, using a cost structure how SpaceX does it, the shuttle price actually goes down like maybe 200 million, 250, maybe. If I'm thinking about this correctly, 450 million TCI is insane. That means the shuttle doesn't cost anything. 200 million a pop. And if you look at the pricing structure based off of that metric, the shuttle is pretty damn cost effective for what it does. Never really thought about it like that. Interesting. Anyway, we'll finish this up with a NASA Spaceflight video here. This is coming from our buddies over at NASA Spaceflight. Mary's the one doing the photography here. Two launches a year, that's still a lot of money. It's because there's no market to launch anything to the moon right now, Chronic. We need to change that. SLS is sustaining a market that doesn't exist. That's part of the reason why it's so expensive. Got to grow the markets in space. Price comes down. More people try to do it. Competition gives us innovation, and it gives us lower prices. Basically, we need a city on the moon. That's what I'm trying to tell you. cryo shells here. Is there a reason the crew needs to work at night? Napfron, no, not really. SpaceX does 3 shifts, though. 3 8-hour shifts. So, work is being done 24 hours a day, dude. Yeah, third shift sucks. Anybody that's ever worked third shifts knows what I'm talking about. Third shift is basically overnights. You basically get there at 9 p.m. and work till 5 a.m. Actually, no, it'd be 9 to 5. And then like 5 to 2, and then 2 to, yeah, 5 to 2, and then 2 to 9. Yeah. 2 a.m. to 9 a.m. is third shift. Yeah, that must suck. This is the ITAR only bin. You can tell it's the ITAR only bin because of the way that it is. J-fans, yeah, exactly. Our third shift is midnight to 9 a.m. Actually, yeah, it would be midnight to... Wait, no. Yeah. 6 to 2, 2 to 10, 10 to 6. Yeah, that's actually the one that sounds right. But I don't know. I mean, there's a bunch of different there's a bunch of different ways you could do 3 shifts, right? Oh, well, that's pretty neat. Will there be Minecraft today? No, I'm gonna do Minecraft on Saturdays now. I think Saturdays will be our dedicated Minecraft day because more people are around. What's the HLS nose cone for? Just a mock-up 95 from what I understand. 10 p.m. to 6 a.m. when you work for BMW. Gotcha. So that's ground service equipment right there. GSE-4, they moved it into the mid-bay. I thought it was 95, yeah. I think that's what it is, yeah. I think they're using it for interior mock-up for the lunar lander, but I could be wrong. In a Texas summer, you want to work the night shift. So 3 is in the mid-bay. I said 4 before. GSE-4 was scrapped. 3 is in the mid-bay. Excuse me. I misspoke. Texas is the only state that I've ever been in where I got sunburn on a cloudy day. You guys talking about working in Texas? I went to the Formula 1 race. In Austin, right? And it was cloudy, so I'm like, nah, I don't need to wear sunblock. It's cloudy. Wrong. 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 No, that didn't work. That was a bad idea. I got sunburned quite literally on a cloudy day. Yep. Texas. Yeah, I don't know. Yeah, Vex, in November. No joke. How are you gonna get sunburned on a cloudy day? How does that even happen? Ugh. Dang you, southern states and your weather. They're putting stringers in on that section right there. Hey, Flight Sim, what's up, dude? Shut up, Kem. That's a good nick. Ooh. OBS right there. Hell yeah. Nice truck. The 97, or 96 or 97 over there. That's nice. He's nice, Ford. I like that Ford. Actually, this Silverado over here ain't bad either. Don't tell anybody I said that, though. it! More dingle bops. Don't have to. I clipped it. You think someone would do that? Just do the opposite of what the streamer says? Huh. Huh. I have no idea, Flight Sim. I'll be honest. I have no freaking clue what the heck this thing is. I don't. It's a spiky thing. Does today end in Y? Yes. Rumored to be part of the 2 structural test stands that will be placed at the launch area. Oh, would you look at that? It's some metal attached to some other metal. Would you look at that? Would you look at it? Would you look at it? Would you just, Mason, would you just look at it? Would you look at it? Look at it. It's pretty neat. Sometimes. What's that, Reagan? Elon can sometimes be optimistic about schedules. Nice. Head Bassmaster. Yep. One of the corner posts for the 8th segment right there. Wait a minute. Hey, wait a minute. This only says 1 gorilla. Yeah, 1 gorilla, 2 gorilla. Besides, look, they're in love. That one has that flange on it and the other ones don't. I wonder. Here's a graphic with TLI estimates. Ooh. Yeah, I'll have to check that out. Jack, what's that? There's that track system. See these little grooves here? Well, not grooves. See these things on the sides there? And then this one has that plate on the top. Yeah. Yeah, Thomas, interesting. Maybe that's the, yeah, the pulley system, like in that, like in this design right here from Lunar Caveman that we looked at yesterday. See? This post has a flange on it for the pulley. So this gray structure, the dark gray structure, can move up and down. So it can catch the booster and then bring it back down and drop it onto the pad. That thing right there. It's going to be cool to see them catch a 220-foot tall silo. I still don't know how they're going to do it, Jack, but it's going to be, yeah, you're right. It's going to be insane. Honestly, I think it won't work. They're not going to catch the SN-20 flight, Wiser. No, that one's going to get expended. There should be a crane up there, 95. Yep. Not with that attitude. Hey, look. Boo and everybody else, here's where I stand. Right here. No. Here's where I stand on this. Catching a booster like that is going to be very difficult. It's difficult, but it's not impossible. There are some things There are some things there that some methods there that haven't been invented yet to get that to happen. But it's possible, why not? They won't catch the first one. No, hell no. No, there's no way. Heck, I don't even think they're going to try to attempt to land the first one back on the pad, guys. They have to prove that they can precisely land one of these things. I wouldn't risk the pad when you do that. That's not a good idea. What I would do is affix landing legs to the bottom of Super Heavy that are fixed. Something like Grasshopper, and then just have a Super Heavy test article just hover around like Grasshopper to prove that it can do a precise landing. And then I would go attempt to catch one. It's got to be within fractions of an inch. No, meter accuracy, give or take. Don't get me wrong. It's about a meter accuracy, right? But they're already within a couple meter accuracy with the drone ships and Falcon 9s. I don't think it's that much of a stretch to be able to get it to within a meter. That should be doable. It's going to be difficult, but it's doable. There's nothing with practical physics here that says that you can't do this. You know? Anything is possible within the confines of physics. It's just some things are more difficult to do, like flipping a freaking grain silo around to get it to land upside down, right? But hey, that worked. You know? Yeah, floating. Yeah, that's probably the most astute render of a catching system that I've seen. Why are they going to try to catch boosters? Because they need to make these things able to be launched 2 times in one day, Solaire. So they can't have one landing on non-retractable landing legs. And making a retractable landing leg would be too heavy. Right? You're losing payload mass if you put stuff on your first stage. Big time. So they opted to make the first stage as simple as possible. Make it as simple as you possibly freaking can. And basically that means putting the landing legs somewhere else. Putting them on the pad. Because if you put them on the pad, like a catching device, right? You can make as big of a landing leg as you want, theoretically, right? You can make it you're not limited to like making it out of stainless steel. You can make it out of straight marine grade steel, right? And you can make the landing legs as heavy as you freaking want to, right? The problem is attaching the landing legs to the booster while it's still flying. That's catching the booster. That's the tough part. But in order to get Starship to be as reliable and as, you know, rapidly reusable as SpaceX wants, yeah, you have to eliminate complexity in the design, and part of that is taking the landing legs off and putting them somewhere else. Let me see, Sevy. Oh, cool cars. Let me see. Let me go through. Wow, that DB5 though. There's a lot of nice cars. I saw a 575 in there. Very nice. Yeah, put the complexity somewhere else where you could put it on the ground where it's easier to maintain, right? Maybe they won't exactly catch the booster, but will only use it to make the velocity 0 when the position is 0, kind of like an assisted suicide burn. Wiser. It doesn't look like that. This is what they're going to do, but how I envisioned this, right, is basically having Super Heavy land on its hold down points. So if you make a version of Super Heavy that has hold down points that are, you know, that's not going to work because your rocket engines get way too close to the ground that way. You basically can't have the rocket nozzles get anywhere near the ground, because if a nozzle touches the ground and it's on and it seals, then it'll blow the nozzle out, right? And it would seal under the weight of the vehicle. How I said to do it would be to have hold down points that kind of go off the sides of the vehicle, and hopefully it's out of the way of the plume to an extent, right? And then basically land super heavy on its hold down points, and then have the landing pad be right near the have the landing pad basically be right near the launch pad. So you have launch pad here, landing pad here, and the tower right here. So it lands the booster, and then the tower, the crane that stacks for integration, you could just attach it and then put it on the pad. You know, like you could just attach the thing straight up. The landing pad would have to be very close to the fixed service structure, but it'd already be close anyway. You know, have some type of specialized catching device, right? Like, you know, basically the booster lands, right? And it plops itself down, and then you immediately grab it and put it right back on the pad. But having it land on the ground first eliminates the margin for error that you would get from catching it. But it really does look like it's going to land onto arms, but it's not that crazy. Falcon 9 is almost accurate enough already doing a suicide burn, let alone a longer burn with translation. I don't think it's impossible, Prey. Look, New Shepard could do it. New Shepard can do a precise landing like that. We've seen it hover and translate sideways. They proved that it can be done with DCX. Why can't it be done with this? DCX did precise landings in the early 90s. YouTube. The Delta Clipper was doing precise landings 30 years ago. I don't know if they'll make them out of titanium, Jack. From what we've seen prototypes, the prototype seem to have been made out of stainless. Yeah, exactly, Buck. It doesn't have to be pinpoint. We're talking about meter to 2 meter deviation here if you engineered the arms correctly. DCX can do a pinpoint landing. That's with Hydrolocks. That's with RL-10s. I think it's going to work like this amusement park ride. To an extent, yeah. Like, look, this thing did a perfectly precise landing. Super Heavy's basically going to do that. It's basically going to do this right here, except it's going to stop right there and just hover, and then the arm will just grab it. It'll basically look like the opposite of a swing arm on a Delta IV launch. And I don't, once again, I don't see any particular thing here that says that you can't do this. It's, don't get me wrong, but also at the same time, that's not easy to do. It is very difficult to get a rocket to hover like that. Very difficult. Yeah, Hellfish, right? Yeah, Rocketology, I'm with you on that one. I mean, if this thing could do it 30 years ago, Super Heavy could do it now. That's not an issue. Yeah, that's what I'm saying, dude. Absolutely. This thing could pinpoint land. This thing could pretty much just is good enough to land right back on where it launched. Like, no problem. It does very precise landings. It's very good at it. Or it was very good at it, I should say. Yeah, look at the date on this. SpaceX did it with Grasshopper. Mm-hmm. See what I'm talking about? I mean, look at how stable that thing is. See, this is what I mean. I think Super Heavy would do something like this, but... Doesn't that take a lot of fuel to do? Well, if Super Heavy is using methane, that means you're increasing efficiency. Along with the stage combustion cycle, you're also increasing efficiency. But we've heard from Elon Musk that Super Heavy won't need to do an entry burn because it's actually, main engine cutoff with Starship is actually going to happen a lot sooner. It's going to be more in line with a Kerolox rocket rather than a methane rocket. A methane rocket, the first stage would burn for a lot longer than a kerosene one does because it's more efficient, right? So the way I see it is that if Super Heavy is not going to fly very far, honestly. It really won't fly that far off into the sky. Starship is going to be doing most of the work to get up into space. But second stages do most of the work. He said to get up into space, right? So if Super Heavy is going to fly on a trajectory that won't have it do a re-entry burn, right? It's not going to need to do an entry burn because it's not going to fly. Main engine cutoff will be very, very quick with Starship, from what Elon has said. So that tells me that it's going to have a lot of fuel when it comes back down and lands, right? It's going to have a lot of fuel. So it should have enough fuel to be able to hover there for at least a couple of seconds and move into position and then catch the thing and then drop it. So basically a Falcon 9 flight trajectory for both vehicles without an entry burn. No. No, not at all. To be honest, we didn't do precise booster landings because it was expensive. And booster throwaway was a better way back then. But they could do precise landings since the 90s. Heck, a lot of VTOLs did very good landings in the 60s and 70s. Yeah, Noctis, that's basically what I'm saying. Yeah. Mm-hmm. Yeah, yes, the yellow pipe structure. If the burn time isn't that long, why would they need so much rocket? So it can hover and precisely and land. And your second stage is frigging gigantic. Arsenal, Starship is almost as big as Super Heavy. It's 2/3 the size. What other rocket do you know that the second stage is 2/3 the size of the first stage? There's nothing. Nothing is like that. Not even Falcon 9 with its payload fairing is 2/3 the size of a first stage, maybe half on a good day. I'm telling you, they engineered this way on purpose. They gave Super Heavy a lot of extra fuel on purpose because of the landing. Yeah, and Starship is just ridiculously capable. And because Starship is refuelable on orbit, who cares? Just get it into space. Think of it like the Grissoms that we launched way back in the day. Who cares if they use all the fuel on the way up? Refuel it and then send it, right? The whole point is about getting that thing up there in the easiest way possible to be able to turn it around in the same day and launch again. So you have to think about Starship in a completely different way than you think about any other rocket. You can't think about it like a rocket in terms of like straight design. So it's not necessarily about making it the lightest, most efficient it can be, right? You're basically taking the Delta V formula and just put the Delta V formula over there for a little while, okay? All right? You have to think about this like a rocket, all right? If we thought about engineering airplanes like we thought about engineering rockets, planes wouldn't have any landing gear. Why? Because it's not really efficient carrying the landing gear around. Right? Yeah, that's not efficient. Just have it land in the ocean, you know, at its destination, and then throw the airplane away, right? It's an analogy that every billionaire aerospace entrepreneur says all the time, right? But they don't really say why, right? So with the rocket, right, in this case, Super Heavy, the landing gear is the extra fuel, right? The landing gear is the extra fuel. That you're not necessarily about. It's not necessarily about efficiency here, right? If Super Heavy was going to launch Starship into space on the most efficient trajectory it possibly could, right? You would expend all of the fuel, and Starship would basically get into orbit with a full tank, almost, well, not a full tank of gas, but like a half tank. But that's not what this is about. If you can launch 2 Starships in a day, right? And one of them's a tanker and the other one's, you know, the actual thing that carries humans, your bottleneck here is not how efficient it is. Your bottleneck is how quick you can launch it. Because if you can launch it and you can refuel it and have it have a full tank of gas, right? In one day, you launch one Starship and then you launch the other. They butt up to each other and they refuel. That right there is the same amount. You'd have the same amount of fuel in the gas tank on a Starship in one day with 2 Starship launches that are rapidly reusable than you would with 1 Starship launch where they expended the first stage, where you expended super heavy. Right? That's the idea here. You got to think about Starship like an airplane. Don't think about it like a rocket. Thinking about it like a rocket is your brain's going to go cuckoo, right? I don't know what that is for what it's worth. Yeah, Shex, right? Is it more efficient to use all the fuel in a... It is more efficient to use all the fuel in the plane and then parachute out at your destination? I mean, once again, you want to get the plane back, right? Planes don't really use that much fuel on landing. It's more getting up there submitted. Rockets are the same way. The Saturn V first stage is shorter than the combined height of the rest of the stages. Though that's just the second. Yeah. Well, if extraordinary engineering requires sometimes some unorthodox stuff. I'm talking about modern carrier rockets, Talon. I mean, the Saturn V, yeah, sure. But if you look at like Atlas, you look at Delta, you look at Falcon, you look at Antares, all of them have extremely tiny second stages and very big first stages, right? This is doable, guys. It's doable. This is very doable. It's going to be difficult, but it's doable. And, you know, I don't know if my opinion means dick in the scheme of things here, but I'd like to think that I know a little bit about how to do this. A little bit. You know, if people are going to disregard what I have to say, that's totally fine. I get it. I'm just some moron on Twitch that likes talking about this. I understand that. Like, but I'd like to think that I'm kind of on the right track in some way, shape, or form. You know? How much more can the 11350 can be extended to? 200 meters maximum on that with that crane. It's called an SDW configuration, if I'm remembering correctly. I saw it already, Forge. We already showed it. Pretty cool, huh? Yeah, when you push the envelope, Hellfish, it's going to be difficult. Always. And then it becomes boring. I want to live in a world where Starship launches are... People regard Starship launches the same way they would regard a plane launching. You'd have to be really into it to really get hyped up to see a plane take off. Rocket watching will be as boring and as mundane to the average person as plane watching is. That's the world I want to live in, where it's boring. Oh, speaking of the extension to the crane. Yeah, there's your crane extension right there. That's the jib mast extension. It also costs more when it's never been done. Yep. Gotta push the envelope, you're gonna need money. And let's be real, Elon Musk has money, so hey. That's what I mean. It's only a matter of time. Only a matter of time. Oh, I see. Yeah, there's been more Chevys infesting this place as of late. Shame. All right, let's see. Anything else? This used to be a nice Ford neighborhood. It's true. It's so true. I think that's everything. Yeah, Hellfish. NASA's paying for the refueling. NASA's funding SpaceX's refueling endeavors. And the FAA controlling space operations, at least the launch operations, is, like I said, groundwork has been laid, dudes. Hellfish, this is, in my opinion, this is a very much in my opinion thing. The groundwork is being laid for Earth-to-Earth Starship. Yeah, it's all the infrastructure, all the foundation infrastructure to get that, to make that work is already being made. At face value, you have Phobos and Deimos, the oil rigs that SpaceX is converting, right? You have that. And then also the FAA policy with how they're regulating rocket launches and stuff. Dude, it's paving the way. And then you realize that SpaceX is talking with SpaceX like 6 or 7 months ago was speaking with the Malaysian government about airspace rights. Yeah, I think it was Malaysia. It may have been... No, it was Malaysia. Yeah. Why would SpaceX be speaking with airspace rights to a company, to a country in Asia, Southeast Asia? Why would that happen? Why would they be doing that? Because they're doing Earth to Earth. That's happening. That's right, Lulz. Exactly. No, that's it, dude. Yep. That's what they're doing. What would happen to supersonic passenger flight or even subsonic flight if Starship Earth-to-Earth becomes available? Well, just like every other form of transportation arsenal, Starship point-to-point makes no sense for regional transport. That's really stupid. You wouldn't fly from, like, New York City to Miami on Starship point-to-point. That's just dumb. Nothing will replace regional air travel. Just like the train, in some way, shape, or form, has never been replaced by the airplane, right? Or the car has never been replaced by the helicopter, right? It only really makes sense if you're going intercontinental with Earth-to-Earth travel. In that regard, supersonic transport, I don't know, man. It's hard to say. I mean, with Starship, if you launched from Los Angeles, you did a Los Angeles to Sydney, probably, I don't know, how long would that take, chat? Like, well, it depends. If you went prograde, it'd probably take like an hour. You went retrograde, 45 minutes. 30 to 45 minutes if you went retrograde. That would be insane. I mean, 90 minutes would be the maximum of any Starship Earth-to-Earth flight. 90 minutes is the maximum. Which is absurd. Yeah, no, there would be no Starship flight, the Earth-to-Earth Starship flight, that would be over 90 minutes. 90 minutes is one rotation, is one orbit in low Earth orbit. No flight would be more than an hour. Literally anywhere in the world in an hour. That's pretty damn cool. That's pretty dang cool, man. Yeah, you could be in Sydney in less than an hour. From where I live right now, that's 14,000 kilometers away. By regular, even by supersonic transport, that would still, if we had a Concorde that had that type of range, right? Even by, and we could fly it over land and people would deal with the sonic booms, that would still take 6-7 hours. Yeah, even with supersonic transport. So, I mean, I guess, Arsenal, your question kind of makes sense in that regard, dude. Like, what do you do with that? Tyler, you like it? Can I order pizza from New York and get it to me in, let's say, Dubai in under 60 minutes? Yeah. Stars from New York City to Dubai would take it wouldn't take 60 minutes. 20 minutes. Look at Falcon 9 when it launches. Falcon 9 when we watch the Starlink missions. In 20 minutes, it's over Saudi Arabia. I mean, if Starship Earth to Earth ever got super affordable, the heck with going down the street and getting Chinese food. You could get Chinese food from China in the same time. Like, you know, the heck with going down and getting the fake stuff at the restaurant. No. Let's just go to China for a day, come back and get real Chinese, man. Can have real sushi in Tokyo in freaking an hour. The main fueling lines aren't hooked up now, so no LN2 can flow into the tanks. Okay. Amazon drone delivery would take longer. It's pretty damn cool, dudes. It's a pretty cool idea. Then you have to take into account getting onto a boat and getting into the rocket, waiting for it to refuel, then flying. It wouldn't take less than an hour. Well, we're talking flight time, 95. Yeah. We're talking flight time. So the whole excursion, so, you know, buying the ticket, getting onto a boat, going through customs, getting on Starship, flying, landing on an oil rig near Sydney, getting on a boat, and being in Sydney. That whole excursion will take 6-7 hours at best? Still worth it. You still have to, heck, the boat transport will take longer than the damn flight. Literally, the boat would take longer. Uber Eats, SpaceX. I wouldn't want to eat immediately and then take all the positive and negative G's. Yeah, it'd be like riding a good thrill ride, Ren. That's about it. But yeah, I guess Arsenal, in terms of, you asked about transonic, dude, or not transonic, supersonic transport. Yeah, I don't know. Janitorial service is going to make bank. The ferry travel to the oil rig would still be more dangerous per mile than rocket travel. Yeah, right. It's true. Yeah, I don't know. Pad is clear. Neat. Is NSF streaming this? Do they have a live stream? I don't think so. The road is closed and SpaceX teams have cleared the pad for Booster 3 testing this evening. Window lasts until midnight, likely an ambient proof test, but the NSF team will go live if they get to cryo. There's another window from 6 a.m. to 8 for Super Heavy. Got it. Yeah, they're going to test the booster. The way I see it is, EJ, is adding Earth-to-Earth travel in a revival of supersonic transport will squash the air transit stack. With small jets still handling short jaunts, your usual 737s handling mid-country travel, and supersonics handling cross-country. Average duration of any particular flight would end up 1 to 2 hours tops. That sounds right, Buck. Yeah, I'll agree with that. Why is Earth-to-Earth a surprise? Nobody ever said it was 117. We're just figuring out how it would fit in with the rest of air or any form of transportation. Just like today, if I wanted, I could get to the airport 30 minutes from me, pass through customs, fly 1 hour to Naples, get a pizza, and come back to the Venice airport in the afternoon. Just for that same amount of time, Starship would be on the other side of the world. True that, man. Can you imagine? Swishio, can you imagine, dude? You could come have lunch with me in a weekend. You could fly across the Atlantic on a Starship, land, meet me, we could get lunch. Freaking you spend the night in a hotel, I go home, and then you leave the next day. Ridiculous. Oh, that'd be so cool. Oh, I want that. I want that. That would be awesome. Fresh ramen from Japan. Yeah, for sure, dudes. For sure. It's possible. It's all out there. We can see why we couldn't do it. You could take a cross-country flight. I mean, I don't know. I don't know if Starship would do Los Angeles to New York. Shoot, if you did, it would take 10 minutes. Seriously, the flight would take, yeah, 10 minutes, probably less. No, 20 minutes maybe. You don't want to liquefy the people on re-entry because of G-forces. Yeah, wouldn't take very long. Plus that view. That's what I'm in it for, Kamir. I already enjoy the view from airplanes at 30,000 feet, dude. See last, please. Small issue with point-to-point, though, launch and landing G-forces. I guess. I mean, Hellfish, if we're flying a similar ascent and descent trajectory as the space shuttle G-load on re-entry never got above 2 Gs, dude. Really smooth ride down. I mean, maybe 4 Gs maximum on the way up. Maybe. You're going to encounter the most amount of G-forces right before main engine cutoff. Because the Raptors can throttle, right? And you have 6 Raptors in Starships. They could just shut down engines on the way up to keep TWR low. Keep low TWR and hence keep acceleration and G-forces low. It's totally doable. There are ways to mitigate the G-forces, man. It's total, yeah. You could fly a steep ascent trajectory. That explains super heavy short flight time. They're gonna fly on a steep ascent trajectory. Steep ascent trajectories aren't very efficient, but they keep the G-load down. They do that now. The Falcon 9 does that right now with Dragon on the way up. Yeah. That makes perfect sense. Yeah, that's why Super Heavy's going to have a short flight time, because they're going to fly a steep trajectory. Basically get Starship up there as fast as you possibly can, and then use the efficiency, the high specific impulse of methane to circularize. It's not going to be the most efficient trajectory, but it's going to be a trajectory that gets your first stage back. You guys got to remember, the other thing is that SpaceX isn't banking on Earth to Earth fully. It's not like they're putting all their eggs in one basket. Obviously, Starship will be great as a space transportation system, but Starship is going to make its money by fixing Starlink, by keeping Starlink up and running. Starlink is the revenue stream for SpaceX, and also the money that they make off launches. But most of the money that they make off launches gets dumped into R&D. If Starlink does what I think it's going to do, SpaceX, Elon Musk will be the first trillionaire. Like, I'm pretty damn sure that that's going to happen, because Starlink, nobody's even close to being able to compete. And if Starlink even captures 1% of global telecommunications, yeah, SpaceX is going to be insane. They'll have more than enough money. Heck, they could operate Earth to Earth at a loss. Starship's primary function would be to maintain the Starlink constellation. Just like Falcon 9 right now. How many Falcon 9 missions this year have been Starlink missions? How many of them have been others? SpaceX has launched like 20 times this year. I think like 3 or 4 of those times have been non-Starlink. Yeah, Swishy, that flip right there, not that bad. Because where the people are is close to where the thing pivots.